Hello, hello, Dr. Power.
Hello, very good morning, sir.
Good morning.
Yeah, Dr. Pawar here, sir. How are you, sir?
Fine, thank you.
Yes, sir. You are most welcome, sir, in Raman 2021, sir. It's proud
Thank
moment for us, sir. We will wait for 10 minutes. Okay, sir.
10 minutes. Okay, okay.
Okay, okay. Thank you, sir. Bye, sir. Good day, sir. Yes, sir.
Waiting.
गुड मॉर्निंग पवार सर. तुमचं माईक अनम्यूट करा सर. पवार सर.
Sir, very good morning, sir. समजाते सर, व्हेरी गुड मॉर्निंग.
हा गुड मॉर्निंग गुड मॉर्निंग गुड मॉर्निंग.
हा, आपण वाट पाहत आहे सर.
गुड
लवकर
मॉर्निंग
वाटत आहे
सर.
की
व्हेरी
9:30ला
गुड
जाईल
मॉर्निंग.
बसता येते.
ओके ओके. हा हा चालेल सर. शेड्यूल झालेलं.
हे बहुतेक येतो. हा, हे आले आले असं असं धरतो मी. तर कसं हे करायचं सांग. तिथंच उभं राहायचं.
गुड मॉर्निंग पवार सर.
गुड मॉर्निंग मॅडम. बस 5 मिनिट वेट पाहू.
अच्छा ठीक आहे. गुड मॉर्निंग तारिक सर.
Oh, good morning.
with the phone. Hello.
Hi sir, good morning sir. You are audible sir. Bageshwar
Good
sir.
morning, sir.
Yeah, good morning. Very good morning. You are
Yes, sir.
audible.
Yes, sir. Yes, sir.
Yes sir.
Okay, sir. Thank you, sir. Thank you.
Just 5 minutes sir.
Okay,
There is
sir.
some
Okay, no problem.
confusion in participants. Uh,
Okay.
9 या 9:30.
Okay. It is 9:30, na, sir?
No, 9.
9. Okay. Okay, sir.
Participants. We are waiting for participants.
Okay, sir. Okay, no problem.
Definite.
Actually, I thought it is from 9:30.
Oh, nice sir.
Good morning, Dr. Bageshwar sir. अनम्यूट करा तुमचं माईक. हा, अनम्यूट करा. अनम्यूट तुम्ही म्यूट आहे. बागेश्वर सर म्यूट आहे म्हटलं तुम्ही. हा
Okay.
हा ओके ओके ओके.
Very good
काय
morning,
म्हणतो बाकी?
madam.
गुड मॉर्निंग, गुड मॉर्निंग, व्हेरी गुड मॉर्निंग म्हटलं.
Very good morning. Good morning to everybody.
हा,
Sir, unwanted noise is there. Yes. There is unwanted noise. Please rectify.
you have to inform it to Dr. Pawar sir. I think Pawar sir is mute.
Okay. Okay. Okay.
Sir, good
Yes,
morning,
yes.
sir.
Okay.
Good morning, sir.
Yes, sir, 5 minutes. We'll start
Okay.
at sharp 9:30,
Okay.
sir.
Sir.
Oh, yes, it's all right.
Okay, sir. Sir, please check why unwanted noise is there.
Actually, there is no noise, sir. I think the problem is at your side.
No, sir.
Uh,
I am alone.
all mics are mute. All mics are mute. Is it okay? Is it okay, sir? Hello, sir. Power, sir.
sir.
Hello.
Hello, Hamzadi sir.
बोलिए सर.
Hamzadi sir.
Yes. Bageshwar. Yes, Bageshwar.
Am I audible?
Yeah. You are.
Yes, sir, you are audible.
You are audible.
Okay, now we'll start. A very good morning to all and welcome to all. On behalf of Raman 2021, and thanks you for joining us on the second day of Raman 2021. I am extremely privileged to welcome Dr. S.S. Aswale ma'am, Associate Professor and Head Department of Chemistry, Lokmanya Tilak Mahavidyalaya Vani.
Thank you, sir.
I am extremely privileged to welcome Dr. S.S. Aswale ma'am, Associate Professor and Head Department of Chemistry, LT College Vani, and the Chairman of today's Technical Session 1. I also honor to welcome Dr. Tarek Muhammad,
Hello,
National
welcome.
Institute for Standards, Giza, Egypt. Dr. Abdul Hakim Deshmukh, Guangdong University of Technology, Gongazhan, China. Dr. Kishore Revatkar, Professor and Head Department of Physics, Dr. Ambedkar Mahavidyalaya, Nagpur. Dr. Gigi Mule, Associate Professor and Head Department of Physics, Sant Gadge Baba, Amravati University. Dr. Hitesh Kole, Head Department of Physics, Sant Gadge Maharaj Mahavidyalaya, Hingna. Welcome to all in Raman 2021. I hand over the responsibility of the technical session to Professor Dr. Bageshwar sir, Mungsaji Maharaj Mahavidyalaya, Dharwad. You are
Okay,
most
sir.
welcome,
Hello.
sir. Bageshwar sir.
Sir, am I audible?
Yes, right, sir.
Okay, sir. So thank you very much, sir. First of all, a very good and lovely morning to one and all. I, Dr. Prashant Bageshwar, one of the co-convener of this great event. I have great honor and privilege to welcome you all to second day of International E-Conference on recent advances in material science and nanotechnology, that is Raman 2021, organized by Department of Physics, Arts, Commerce and Science College Maregaon in association with Department of Physics, Hulsing Naik Mahavidyalaya, Pusat. Friends, for day 2, I welcome all the resource persons who are going to deliver plenary talks and invited talks. Now, I feel very privileged to welcome Dr. A.N. Gharte sir, Principal, ACS College Maregaon. I take this opportunity to welcome convener of this international event, Dr. N.R. Pawar sir. Dr. Pawar sir work very hard for this beautiful and wonderful gathering. So I salute to his hard work and dedications. Once again, I welcome you, sir.
Thank you,
I
sir.
extend
Sir,
my
it's collective
heartiest
effort.
welcome to Dr. A.B. Patil, sir. Okay, sir. I extend my heartiest welcome to Dr. A.B. Patil, sir, who is principal of Hulsing Naik Mahavidyalaya, Pusat. I would like to welcome my dear colleagues and friend, Dr. P.T. Hamzade, sir, who is organizing secretary of this international event. I grab this opportunity to welcome all the resource persons, professors, researchers, students, and ladies and gentlemen. As sir has rightly mentioned, today we have planned 2 plenary talks, and 3 invited talks by eminent resource persons. So, friends, somebody has rightly said that well begun is half done. Yes, it is absolutely true. Yesterday was a first day, and it was full of galaxies of intellectuals. All the sessions which were conducted, it was full of knowledge, interactions. Definitely, we all are the eyewitnesses of yesterday's proceedings. I have proud to mention we got a very good comments and reflections from every nooks and corners. I hope that you have been enjoyed everything. So, ladies and gentlemen, without wasting much time, we now start today's first technical session. So, I have a great pleasure to associate with you all, and I have proud to mention that chairman for today's first technical session is none other than Dr. Sunanda Shashikant Aswale. So at this moment, I grab this opportunity to introduce Dr. Sunanda ma'am. She did her MSc in chemistry. She completed PhD, SET, B.Ed, as well as additional English literature. Dr. Sunanda ma'am is currently working as an associate professor and head Department of Chemistry, Lokmanya Tilak Mahavidyalaya, Gani, Maharashtra. Ma'am received prestigious award, Bharat Shiksha Ratan Award by Global Society for Health and Educational Growth, New Delhi. Dr. Sunanda ma'am received DLIT by Radhakrishnan Teachers Association in collaboration with South America University. Dr. Aswale ma'am is a recognized PhD supervisor in chemistry. Many students are working under her able guidance, and recently one of them is awarded PhD. Dr. Aswale ma'am has published, presented more than 100 research papers in international and national journals, as well as in international and national conferences. Madam work as an organizing secretary and coordinator of national conference and international webinars in chemistry. Dr. Sunanda ma'am is a life member of many prestigious bodies, research bodies, and also a member of educational editorial board of international and national journals. Dr. Sunanda ma'am is also work on various committees of Sant Gadge Baba Amravati University, Amravati as a member. She is the author of 2 books of chemistry and also a co-author of a textbook of chemistry. As ma'am also work as an NSS officer, she organized many programs under her able guidance. Dr. Aswade ma'am has mobilized cooperate resources of have and nots of the society and motivated multinational companies to donate handsome amount of orphans houses at Vani, Maharashtra. Presently, Dr. Sunanda ma'am working as a working for the guidance for career and job opportunities on YouTube channel. So, with this brief introduction, ma'am, once again I welcome you. And before starts the proceeding, I request Dr. Shashikant ji Aswale sir to welcome by a memento and a flower to Dr. Sunanda ma'am. So please, Shashikant
Thank you,
Aswale
sir. I actually welcome Sunanda madam, not virtually welcoming her. I actually welcoming her by offering flowers, then memento, and a certificate certificate. Thank you, sir.
Certificates of participation.
Thank you, sir.
Okay.
Yes, sir.
Thank you very
Thank
much,
you, sir. Thank you, sir. Sir, thank you.
So with this brief introduction, now I request madam. So please start the proceedings, ma'am. The whole stage is yours. So I once again request you to start the proceeding of the first technical session. Thank you, ma'am. Thank you.
Thank you, sir. Thank you, sir. Very good morning, one and all. First of all, I would like to thank the organizers of this e-conference, especially Dr. N.R. Pawar, for giving me the opportunity to chair this technical space session. All the dignitaries, all the delegates, and all my respected participants. I am Dr. Sunanda Shashikant Aswale, Head Department of Chemistry, Lokmanya Tilak Mahavidyalaya, Vyagwani. I feel privileged to welcome you all on behalf of the Physics Department of the two college, Arts, Commerce, Science College Marigaon and PN College Pusan. In these 3 days international e-conference on recent advances in material science and nanotechnology, having a very unique name which is closely related with the two subjects, physics and chemistry, Raman 2021. I would like to share that in this technical session there are 5 talks, out of which the 2 are plenary talk and 3 are invited talk. Each session is of the 30 minutes, and the first plenary talk is of Dr. Tariq sir. He is from Egypt. Second talk is of Dr. Abdul sir. He is from China. And third talk is of Dr. Kishore Revatkar sir. He is from Nagpur. And the fourth talk is of Dr. Gigi Mule. He is from Amravati. And the last talk is of the Dr. Ritesh Kohle sir. He is from Hingna, Nagpur. Ladies and gentlemen, let's move on the first speaker of the plenary talk. He is very renowned personality, eminent personality, Dr. Tariq sir. I would like to welcome Dr. Tariq sir, and therefore I would like to invite Dr. N.R. Pawar, convener of this conference, to welcome Dr. Tariq sir.
Hello, good morning, sir.
Good morning, Dr. Bauer. Thank you, Dr.
Yes, sir.
Sananda.
It's the token of love and appreciation, sir. Yes, sir.
Thank you.
It's token of love and appreciation, sir. Thank you, sir. Thank you, sir. You are most welcome, sir.
Thank you.
This is the pandemic period. There is no choice other than virtual welcome. We are welcome you by virtual way. It is, we know Dr. Tariq sir is a well-known authority on National Institute of Standard in IS. He is in Department of Acoustic, Giza, Egypt, and Ministry of Higher Education and Scientific Research. Now I request Dr. Tariq sir to deliver his talk.
Okay, thank you, Dr. Sananda. First, I would like to thank all the organizing committee for this conference. And thank you for giving me this chance to introduce this work. Thank you. I will share.
Yes, sir, you can share, sir. Share your slides.
Yes, okay.
Yes, sir. Your slide is visible, sir. Yes, sir. You are audible. Okay, sir.
Okay. Title: Acoustical Metrology and Materials for Different Applications. Presented by Tariq El-Bashir, Department of Acoustics, National Institute of Standard, Egypt. Outlines: Acoustical metrology, noise and its effects, noise reduction, materials for sound absorption, applications for acoustical materials, polyurethane composite, polyurethane foam, silica fume, and polyurethane foam slash sawdust. Non-acoustical and acoustical properties of composite. Conclusions. Let me first give small information about my institute. NIS is considered the National Meteorology Institute of Egypt. At our institute, we perform the measurement and calibration for all types of devices. Also, in addition with that, we perform research in order to improve the capabilities, our capabilities. Yes. Sorry, sometimes slow connection.
No audio, sir. Audio is not coming.
Just a second.
There is a problem of audio.
Sorry for this. Sorry for this. The acoustic department, at the acoustic department, we have three branches. The first branch is the electroacoustic branch. At this branch, we perform the calibration for sound level meters and microphones and the acoustical calibrator. The second branch is the audiometry branch. At this branch, we have both test room. At this room, we perform hearing threshold measurement for the humans. Also, we perform the calibration of audiometers that present at the hospitals and clinics by using the artificial ear. Artificial ear consists of microphone and the preamplifier simulating the human ear. Yes. The third branch for the materials, the measurement of sound absorption of different materials. Okay. Noise sources and its effect. Noise is considered as a big public health crisis because noise can affect the human hearing and make the people very angry. The noise may be industrial noise, uh, from the machines, the different type of machines, and can affect the worker hearing. It can make them with deafness. It can cause hearing impairment. Environmental environmental noise comes from the transportation, the loudspeaker, and these are the airborne type of noises. And the structure borne type of noise uh, uh, comes from the vibrations. Yes. Okay. From noise we can noise can affect our hearing because a noise can cause increasing blood pressure of the human, can make us annoyed. It can cause hearing deafness. The human ear consists of the outer ear, middle ear, and the inner ear. The biggest problem can happen at this part, at the cochlea and the synapse. This synapse connected to the brain. The sound wave converted to electrical wave defined by the brain. So noise can cause us crazy. Next, the application for acoustical materials. The acoustical materials have different application in many sectors, like automotive, like building, where in the automotive there is noise comes from the engine and transferred to the people inside or the interior of the car. Yes. Next. Is the materials for sound absorption, reducing noise by using some materials and some sound absorbing material to minimize the harm of the noise pollution. The sound absorption material can be categorized into two categories: the resonant sound absorption material and the porous sound absorption material. The porous material combines the properties of lightweight, eco-friendly, and sometimes the absorption occurs with wide band frequency range, concluding the low and high frequency range. The resonance material may involve a single Helmholtz resonator. The resonant type of absorption material, like in this photo. This photo is a microperforated panel consists of many holes. Holes are very small in size, maybe in zero point 0.5 millimeter, and there is Helmholtz resonator. This is the resonator. The resonator consists of a neck and a cavity. The neck has some dimension, the area, the surface area, and length, and there is a cavity there. When the sound come the neck, it bounce back and forth, then may be absorbed at this part, and the resonance frequency determined by this equation V, which is the sound velocity over 2 by root mean square A by VL. A surface area of the cavity, V is the volume of the cavity, and the length. This Helmholtz resonator looks like a mass spring system. Yes, they perforated panels like this. This picture at the industrial zone at the United Kingdom. There is many machines inside, and the noise transmitted to the outer side of the environment and make some people harmful. So how to heal this problem? Using the perforated panel. This perforated panel consists of slits. Slits maybe in centimeter, maybe cut it in slits in centimeters, and presented in this structure. And this is effective for reducing the noise comes from the machines inside this industry. The third, membrane absorber. The membrane absorber can be prepared like nanofibers, and this material maybe cover the traditional material, which is maybe polyurethane, polystyrene foam, or other, and this is effective for reducing the noise. Also, the microperforated panel designed like in our work, we designed the microperforated panel. The whole size was in 1 millimeter, and the material is lightweight aluminum in thickness of 1.5 millimeter, and the perforation ratio, the good perforation ratio that can affect the noise is approximately between 1 to 5 percentage. You may use new design in order to reduce this type of noise. The low frequency noise is the most harmful type of noises due to the high wavelengths. Low frequency means high wavelengths and can penetrate the structure very deeply. If you use this microperforated panel with material which is porous material, you can cover this microperforated panel with the porous material in order to get a good absorption at the low frequency range and with wide bandwidth. Yes. This research below presented the relation between the thickness and the alpha. Alpha, the sound absorption coefficient, and the frequency, the very low frequency range from 100 to 200 hertz. At this research, he presented a graphene polymer composite, and in his study, he used they use 1 centimeter material thickness, and they get approximately zero point 0.7 at this zero point 0.7 sound absorption coefficient at this range of frequency, and it is very important. You can see other types of material like a microperforated panel which has a drawback because it can reduce the noise at the low frequency, but they are narrow band. So we use always porous materials, porous material with, which can increase the absorption coefficient in addition with microperforated panel at this low frequency. Yes. Measurement of sound absorption using two microphone impedance tube. At our laboratory, we measure the sound absorption coefficient of the material using this tube, where the material put it inside this holder in the middle, and there is a noise source at this end. The material is here. The idea is that when the sound incident on the material, some of the sound wave may be absorbed by the material and other transmitted. Some small type, if the material is porous, small amount reflected by the material. This measurement run by software, and there is sign generator to generate different frequency, and there is amplifier to amplify the signal. Sorry. Just a second. Okay. Polymer with improved sound absorbing properties. This research were performed by me and two of my colleagues in the chemistry labs. They prepared polyurethane sawdust and polyurethane silica fume composite at different percentage filler percentage 1% up to 5 weight%, 1, 3, 4, 5% using one shot free rise foaming process. They prepared it into different thickness 2 centimeter and 4 centimeter. Yes. After preparing the material, you need to characterize it. The non-acoustic properties, which is important in the absorption of noise or absorption of sound, is the porosity. In porosity in percentage, it may be measured using the water saturation method, and where phi equal to VW over Vs. VW can calculate it from the mass of wet minus mass of dry over rho of water, and Vs can calculate it from the volume of the material. Yes. The second parameter, which is very important, is the air permeability, air flow resistivity. They are opposite to each other. The air permeability was tested using the air permeability tester FX 300. And the airflow resistivity can be calculated and detected and calculated from the air permeability, where the air permeability equal to S, which is the surface area of the material, and delta B is the pressure drop. During the measurement of the air permeability, we used to pressure 100 Pascal and 200 Pascal, so the pressure drop is 100 Pascal. From the air permeability, we calculate the velocity. This is the velocity, and the T is the thickness. So from the air permeability, we calculate U. After calculating U, you can calculate the air resistivity, which means the resistance of the material to the flow of air. Yes. The third parameter is the tortuosity. Tortuosity means that sound not move in a straight line, but it can move in a zigzag. So when the incident waves or incident sound wave come to the material, some of it absorbed and some of it transmitted, but the motion of the sound wave inside the material affected by the filler. If the material is a composite material, this filler fills the pores, these holes or these pores. So
आवाज बंद करून
when
ठेवायचा
the,
आहे तुम्हाला कमी आवाज करायचा इथे जा
when the sound come and find a closed pore, it takes another path to move. So the absorption increases due to increasing the amount of heat. The tortuosity can be calculated from this equation using the porosity parameter. At this research, which is polyurethane with silica fume and sawdust, the porosity of the prepared polyurethane is approximately 0.6. It can be multiplied by 100, so 60% porosity. The polyurethane slash silica fume, the porosity decreased to be 55. And in the case of polyurethane sawdust, the porosity increased to 50%. The airflow, you can find the airflow resistivity increases when you move to a when you prepare a composite material rather than the neat polymer or the polyurethane. The silica fume has higher airflow resistivity than polyurethane itself, and the sawdust polyurethane has airflow resistivity more than the others, which means the sound absorption will be affected in a good behavior. The tortuosity, we can find that the tortuosity increases in the case of polyurethane so dust foam, and this means the motion of the sound wave in zigzag motion and take a higher path, and the absorption may be higher. The morphology is one of the most important things. The scanning electron microscope. Here we can find the scanning electron microscope of the polyurethane itself. You can find the cavities, and each cavity has many pores. If you add a filler, you can find some closed and some partially closed pores. You can, from the scanning, you can deduce the cavity diameter and the pore size, and you can also calculate the porosity by this way. Also, a second way to calculate the porosity. The, the acoustical property, the acoustical absorption property. Here we can find from this figure the relation between sound absorption coefficient alpha, which is the ratio between the absorbed to the incident sound wave versus third octave band frequency. You can find that the absorption increases with increasing frequency, and this logically up to 3150 hertz. You can find the highest amplitude for the polyurethane itself. These two figures is for the two different thickness of polyurethane silica fume polyurethane silica fume in thickness of 4 centimeter. What you can find here that the absorption for different percentage of filler varied and increased with increasing in frequency. We concentrated on the low frequency, which is the most important for us. You can find the highest absorption occurs at 1600 hertz. Here in the other side, you can find that there is broadening in the behavior of the lions, and this is very important. Also, you can find the absorption moves toward the lower frequency. The absorption here at 1600, here become at 1000 or less. And this is very important for many applications. The two figures for two different thickness, 2 centimeter and 4 centimeter, polyurethane, silica, sawdust composite. Here also you can find that the absorption increases with increasing the frequency, and you can find the sum of ratio is higher than the others. In the other side, you can find the absorption occur at lower frequencies. So the absorption shifted towards the lower frequency, and this is very important for different application, as I said, and there is broadening. You can find a broadening. Conclusions. The rule of NIS is to provide the researcher with a big leap forward with regard to research and provide the leadership in measurement science at Egypt and Africa. Material science is very important in many applications and is considered as a magic solution. Noise control may take a higher concentration in the future to save the human health. Passive noise control proves the ability of material to reduce the unwanted sound. The physical properties like density, thickness, and airflow resistivity, etc. of the material is very important and affects the acoustical performance. Polyurethane foam and its composite play a crucial role in the sound absorption application. The composite of polyurethane silica fume and polyurethane sawdust can give good absorption performance with the low frequency range. Increasing the thickness may shift the absorption toward lower frequency. I would like to thank the organizing committee, Prof. Umbarakash and Prof. Power, also the chairman, Prof. Sananda. Thank you.
Thank you, sir. Thank you, sir.
Thank you.
Actually, it is very stimulating presentation, sir. Many audience would like to ask many questions to you, but due to time limit, I permit few audience to ask. If you have any queries, you can ask the question, sir. Okay, sir.
Okay.
Okay. You have presented very.
Ma'am, hello.
Huh?
Hello, good morning, ma'am. Please wait. I will check the chat.
Huh?
Okay.
Okay.
Yeah, sir. There is no any question in the chat box, sir. Okay, sir.
You are explaining in very simple way, sir. So there is no question. Your topic is very, very interesting, sir. Acoustic methodology and materials, and you have discussed the various applications of the acoustic material. We have also worked in the same field, but we don't know such intensity of the research. You have explained it very well. Thank you, sir.
Thank you.
Madam, hello. Audio, any queries from the participants? Yes, unmute yourself. Any queries from participants?
No queries, sir.
Okay. Umanwar, sir? Umanwar, sir? Okay, sir. Okay, sir. Okay, ma'am. Proceed.
Okay. Thank you, sir. On behalf of the organizing committee,
Sir,
and from all the participants,
Sir, join karan mana.
I would like to thank Dr. Tariq sir for giving such interesting presentation, and we are so lucky that you are with us and sharing your ideas. Thank you very much, sir. Thank you for giving us prestigious time. Thank you, sir. Now,
Hello, ma'am. 1 minute. 1 minute. There is one query. Okay, ma'am. 1 minute. 1 minute. Yes, yes, yes. 1 minute, ma'am.
How? Okay, sir.
Okay. Good morning, sir. Good morning, Chimankar, sir. You are most welcome, sir. Chimankar, sir.
Sir.
Sir, you are co-host, sir.
Yeah.
Yes, sir. Very good morning, sir. You are most welcome, sir.
Yes, sir. Very good morning to all. Tariq, sir, very good morning. Tariq, sir.
Good morning.
Good morning.
Good morning.
Very nice
good
talk,
morning.
sir. Very nice talk on the sound exhaustion measurements. So thanks to join this conference Raman 2021. So thanks to organizers to invite my friend Dr. Tariq Hussain for this Raman 2021. Thanks to all.
Okay. Can I continue, sir?
Ma'am. Okay, ma'am.
Just okay, okay, sir. Thank you, sir. Now let's move to the second talk on invited talk of this session. For this invited talk, may I request Dr. Revatkar sir for this invited talk. He is professor and head of Department of Chemistry.
Hello, Dr.
Yes, sir.
Pawar sir.
Yes, sir.
Pawar sir. Dr.
Yes, sir.
Petro should
मी काय म्हटलं मी नंतर लावतो फोन ते
Dr. Petro sir want to ask the question.
Yes, right, sir. Okay, sir.
Okay,
ma'am,
sir.
just 1 minute,
Oh,
ma'am.
okay, sir.
Okay, sir.
Dr. Petro sir.
Yes, 1 minute, sir. Very good morning, Professor Petro. Hello. Very good morning, sir.
His microphone, actually his microphone is switched off, so he cannot ask a question. He cannot ask question.
1 minute,
His
sir.
microphone is switched off.
Yes, 1 minute, sir.
Yeah.
Sir, you are co-host, sir. Hello.
Sir, unmute yourself, please, sir. Petro sir, you unmute yourself.
Sir, you are co-host, sir. Petro sir, you unmute yourself from your side, sir.
Yes, okay.
Okay. Now it's okay.
Yeah.
1 minute, sir.
Oh, yeah, we listen you, sir.
Hello. No, sir. Sir, he is unable to unmute himself.
He has some technical issues. Okay.
Ma'am. Okay, ma'am.
Continue. Unmute, madam.
Okay. It is my great pleasure to introduce the renowned personality of this session, Dr. Revatkar sir. He is with us. He is very eminent personality and he use biodata. Dr. Kishore Revatkar is head and professor of the Dr. Ambedkar College, Nagpur, and teaching to UG and PG department, especially nanoscience and nanotechnology. He is the faculty and coordinator of the nanoscience and nanotechnology. He is faculty member of BOS, RTM Nagpur, and RRC Gondwana University. He has received the Best Teacher Award of 2021 of RTM Nagpur. He is a member of various academics, professional and administrative organization. He is president of the Marathi Vignan Parishad Navargaon chapter and founder secretary of STAMI. He is president of Vidarbha University Physics Teacher Association since 2018 till date.
Sir, good morning, sir.
He is an author of 6 books and credit more than 129 research paper in national and international journals and got award in various papers, including the prestigious award of the America. Lower of several international journals. 28 students are awarded with PhD and more than 10 students are working with him for the PhD under his guidance.
Right.
Has completed 4 major and minor research projects and also 4 Indian government patents. He successfully organized various national, international conferences seminars, workshop. He visited various university and the institutions of the various countries. More than 10 countries he visited for the research. Such a renowned personality he is, and we are so lucky that such a renowned personality is with us for sharing his ideas. And now I request Dr.
Amit
Amit
Bansal.
Bansal sir to welcome virtually Dr. Kishore Revatkar sir.
Congratulations, sir. It's a token of love and appreciation, sir.
Yeah, thank you. Thank you very much.
Thank you, sir. Thank you.
Nicely, you are giving at the place itself. No need to come to your place.
Thank you, sir. Thank you, sir.
Thank you very much.
Thank you, sir.
Shall I start my presentation?
So you can start your
Before
presentation.
that, may I know how much time you are giving me?
30 minutes, sir.
30 minutes. So it is about 10:25. So
Okay,
by 12 o'clock or 5 minutes before 12 o'clock, I can close down.
Okay, okay.
Okay, thank you. Thank you very much. So
Thank you,
at
sir.
the outset, I thanks Dr. Nilesh Pawar sir for giving me this opportunity to share my views and aspects about a few things which I am doing in my place. I am actually undergraduate teacher, and but the college where I am working is a big institution wherein we have the PG, post PG, and research center also, wherein a lot of students are pursuing their research work. And I also thanks the chairman, Dr. A.N. Gharde, principal of the Art, Commerce and Science College, Maregaon, and all the organizing committee for giving me this particular opportunity to share my thoughts and views. The topic of this conference, Raman, RAMN 2021, is recent advances in material science and nanotechnology. Though I am working on nanotechnology, we have 4 patents on related with nanotechnology or nanomaterials also. But today I have chosen this topic, scientific challenges and achievements of the 21st century, a perspective. Just I am giving a perspective is only because a lot of research that has been carried out around the globe on not only, and the hottest topic is the advances in nanotechnology. So a lot of people are working, they have diverted their work towards the nanotechnology, as this nanotechnology is a boom, you can say that, because it has a potential to give a lot of applications, to a lot of comforts to the human beings by doing research. As we all know, some of the fruits that we are already enjoying out of the nanotechnology is one simple example that I would like to give you is of a pen drive. So when the computers were born, so that time they were not having the external hard disk, but now after a lot of changes from floppy disk to the hard disk, and today we can have 1 terabyte external device also, and that is all due to the you can say that the colossal magnetoresistance CMR and the giant magnetoresistance technology that has been developed because of the nanotechnology. But let me divert your attention towards the problem that it is in Hindi, it is said that Sar Salamat to Pagdi Pachas. So it means that if the very human race is alive on this planet, then only we can think about the lot of technologies and lot of developments in and around. Because whatever the technologies that has been developed or that has been going to be discovered, or you can say that the whatever the research that will be going on is only to give a more and more comfort to the human being. But unless human race is not safe on this planet, how can we go with the recent advances in the technology or recent advancement? with this perspective, let me start with my presentation. And my presentation carries about a nanomaterial. I'll definitely talking about a nanomaterial, provided the time is there, because I had given 30 minutes, and in 30 minutes, lot of things that I have to cover. So maybe I can skip some of my slides. The total number of slides are something about 80-85, but even if I can just run quickly through these slides, I will not be able to continue complete my all presentation. But some of the things that I would like to just touch it to the researcher, because I know that Nilesh has registered a lot of you can say that the faculties from throughout the India, and some of the research students also, though those students want to pursue the research in various you can say that various field which are related with the nanomaterials. So there are some of the things that I have depicted here. Nanomaterials, phase change material. This is something new, that will be new research that will be going on. And this phase change material, that will be definitely, of course, the nano thing is there. The nano composite, other advanced material, of course, a nanomaterial, and some of the nanomaterial that has been used as a magnetic material, because I am basically working on a magnetic material. And few things that I want to put forth to the learned class, which has joined as a participant or a delegates today and present guest, that's something about environmental pollution. And you can say that the pollution and environmental related issues, then global warming is one of the challenge, a threatening challenge, very you can say that the threatening challenge in front of all the worlds, all the countries in the world, you can say that. And something that every day when a new industry that is erupting, or that is growing, or that is been coming up, will be definitely going to add to certain extent to the greenhouse effect. So as you can see the picture, from the picture, that in 2020 we expect that in today's day, that 2020 the earth is supposed to be something like that, the blue, if you look at from from the moon or from any planet, then the earth something looks like to. Now this earth, very earth, how we are going to change with the help of the global warming, so that I don't know that in 2050 or 2090 or 2095 or 2030 or something, whatever that year. So that is in our hand, that how we can preserve our earth is one of the important thing. And I think that all the researcher should think about that, how we can do the research work which will going to help our earth. As we all know that the flood, this is a recent flood in a Mumbai, wherein a lot of, recently means some 4 or 5 months back, this flood has occurred in Mumbai. This is a picture from Mumbai, and as you can see, almost the cars are submerged in this case. Then this is a drought, then the landsliding, and whatever addition that will be given, that will be made by the industries in terms of the pollution, so that we have to think over it. And this is you can say that the fire, jungle fire, you can say that this is these are the challenges. The climate change, as we have noticed from last some you can say that the last some 50-60 years, there is a change in the climate, and that has been induced the global warming. So this climate change refers to the change of state in a climate that can be identified by the changes in the mean and the variability of its property. Now I request someone to add these people, because these names are coming, so that simultaneously because that will distract my attention. So Sauli madam, please add those people who are joining in between this. And so likewise, in the mid of the 20th century, you can say that, and its projected continuous greenhouse effect. So these are the new terminologies that have been come up. And we know that because of that, what has been happening, that there is a lot of things, that a lot of changes, the water or the sea level that has been rise, and there is an upward trend. I can show you some of the slides that how the temperature that has been changing and that has been creating. This is one of the factor that will be adding to a systematic adding of the greenhouse effect, you can say that. And that greenhouse, what are the greenhouse gases, as we all know. So I'm not going into it, into the details of that. I suppose that many of us we know, or almost all people know this, that whatever the radiations that has been coming from the sun, that will be received by the earth. Some of the radiations, we can say that they are reflected by the earth's atmosphere, and some of the radiations they are directly penetrating, and like these radiations are ultraviolet radiations. So these ultraviolet radiations are causing a damage. Of course we want the ultraviolet radiations, but the limit, and this blocking of the ultraviolet radiations, that is being done by the you can say that by the ozone layer, and we all know that there is a huge hole to the ozone layer, and that we have to repair, and we cannot do, because that hole, or that the defected area, that defect that has been created, because in the ozone layer, that is a huge size that one cannot do that, and these are all some of the greenhouse gases. This all we know that the eastern Vidarbha region, as we are living in the Vidarbha region, so eastern Vidarbha region, you can say that like Chandrapur and Gadchiroli, and you can say that Bhandara and Gondia, and some part of the Andhra Pradesh, which is been the border area to the Vidarbha. So there the people are facing the problem of growing a paddy. So because they are not getting enough rain. So that because of that, so a lot of problems are there with the crop, the paddy crop, which is the staple food of this Vidarbha region, of this district which I said right now. So that we have to think. So what causes the global warming? So if you see that, if you see, the carbon dioxide is one of the main constituent of the global warming, or of that region, particular region, wherein this carbon dioxide that will be emitted in the air as a pollutant, and this atmosphere is collecting. So there is a thick blanket, you can say that, that has been wrapping around the earth, and trapping the sun's radiations that are reflected from the earth's surface, that they are being trapped inside the earth atmosphere. So they cannot get outside of this blanket, or get outside of the earth atmosphere. So therefore that will be causing the global warming. And then there are other pollutants also. So now, is the earth getting hotter? Yeah, definitely is the earth getting hotter. So although local temperature fluctuates naturally, but we are also experiencing that there is a definitely increase in the temperature of the earth. In the month of the May, particularly, the temperature that we receive, even the Vani area or this Maregaon area where this conference host is there, so that area is also getting hotter. Akola is one of the area of you can say that the Maharashtra district. Akola is one of the district wherein the temperature is always high. Then, and even Chandrapur also, where a lot of coal mines are there. So these are experiencing the hottest area. So 10 hottest year on the record all over occurred in 1990s. So in 1990s, we have seen from in the last 10 years, you can say that, but 20 years back, the temperature that has been experienced on the Earth's surface was very large. And we are saying that we cannot curb the global warming emission average temperature. That could be 3 to 9 degree higher by the end of the century. So that is possible because in 1920s we have received that. So if you see the global disparity in the carbon footprint, that who is creating a lot of carbon, because as we know that the USA, Canada, or this USA and the European countries, we are saying that they are developing countries. Now what are they doing? So they are adding the CO2 emission and the CFL emission also to the atmosphere. So if you see the on an average per capita CO2 emission in the world's largest economies, in this is of course 2016, 4 years back, this report is there, but you can see USA is having, and beside USA the adjacent countries. So these countries are adding more pollution. Now, after that, the South Korea, one of the industrial country, you can say that a lot of industries are there. Lot of you can say that the utensils or the gadgets, electronic gadgets are mostly coming in India from the South Korea and China. So you can see the India is at the bottom of all these countries where the emission in India is very small, because as we know that India is a country whose economy is depending upon the farming. So a lot of trees, lot of herbs are there, and lot of lot of different kind of the grain fields are there. So we are having less number of the industries, though there are some district or some places where the lot of industrial pollutions are there. One such you can say that the city is Delhi. Then you can say a metro city, of course. Then Mumbai, then Kolkata and Chennai. These are all adding. But if you compare the other part of the country, India, then they are less. So likewise, this is what you can say. But USA is on the top. It has been topping the addition of the pollution, you can say that. So now this is what you can say that the annual kind of the thing which we can say. So I'm skipping this, but in general, if you see that the percentage of the carbon dioxide will be more, 29.5%, and likewise the methanes are there. So these are all the different you can say that the transportation of fuel, then power station, wastage of the disposal and treatment. These are the different colors we have indicated for different kind of the polluting aspects. And then on this, if you see the carbon, in case of the carbon, the most 29.5% carbon is coming from the power station. This power station is electric power generations also. Then in case of a methane, the agriculture byproducts, many a times we think that from the agriculture we are not getting any kind of the pollution, but no, I know, because I have lived in the paddy field area in the Chandrapur district, wherein annually a byproduct of the rice that will be taken, wherein in the rice field it is a crop of 120 to 140 150 days crop. So within 150 days the crop will be coming, or the whatever the products that can be taken to the market directly from the field. So wherein during the you can say that during the paddy season, when the crop is there in the green form, that time lot of methane that will be emitted out, and you can see that this methane is also one of the green gases. I have observed some of the effect of the methane is that the tanning of the skin. I have seen those people who are working in the paddy field during the season of the paddy. I have seen that their skin get tanning, a darkening of the skin I have observed, and that is only because of the methane. So a lot of methane gas will be evolved over there. Then there is another the product is a nitrous oxide, you can say that. Then these are some of the areas wherein the global warming that we can say that. So in 1990s the risk was very less, but as we can move toward the 21st century, by 2025 you can see that the risk will be already there, risk to many, then large increase, and these are the some of the aspects that we have considered. So by 21st of the by the end of the 20th of the century, 21st century, you can say that there we can say that the risk of irreversible large scale and abrupt transition that will be taken, that's something that we can recycle it, something we can reverse it, but some of the changes which are called as a chemical changes, that cannot be reversed back. Chemical changes, if we burn a wood, we cannot bring a wood from the ash itself. So that is a permanent change that we can say that the chemical, some of the physical changes that can be brought down. So these are some of the areas. So my intention to explain you, to give the briefing about this is only because that we are the scientists, we at present we are running on a forefront. So definitely mostly the nano things are there, so which is having the application in various area: industrial area, electronic, environment, renewable energy, textile, biomedical, healthcare, and food and agriculture. So we have to carry out our research. We have to think that how minimal I can affect the atmosphere, how minimum, or to the extent I can say that to a zero level, how could I change my research line, so that it will not going to add in any way to to destroy the natural, you can say that the natural atmosphere, and not going to add to the pollution. Okay, so these are the small areas where anybody can think about that. Likewise, I'm skipping these slides. Then, as we all know that the nanoparticles are having a small size, high surface to volume ratios. These are some of the things. So the nanotechnology we can do with a tailoring of a bulk property of a material. We can tailor them, we can curtail them, we can cut them, we can shape them in whatever way we can change them. So by this nanotechnology or nanomaterial is a result of size effect. So as we can reduce the size, we can do that. So nanotechnology is having a lot of applications in medicine, energy, material, electronics, and there are a lot of applications are there. Yeah, this is one such slides where I always bring it to the notice of the researcher that in 1980s, when we think about a 2 GB, you can say that the storage device, hard disk, you can say that it cost around $80,000. And now, if you compare in 2020, this year, then 2 GB pen drive you can get this 2 GB pen drive. You can check the size also, size of this 2 GB, and this is about the 2 GB pen drive, even smaller than this. The comparison size that has been reduced, because I told you the GMR and CMR technology is playing a vital role in reducing the size, reducing the cost. 350 rupees, and you can just compare. So many fold times the price that has been reduced down. So that is possible. And currently the research shows that 1 terabyte of memory can fit on the head of a small pin. So such a small reduction in the size, and again the people are thinking about now from nano to pico meter. People are started working on the pico material also, so that in that case again that we can reduce, and so many wonderful applications that can come forward because of this. So one such application you can say that is of a transistor. So we started with this transistor. Now we can have a nano transistors. I don't have much of the time, so that is why I'm skipping it fastly. So I only have 10 minutes. So now the HP, Hewlett Packard, has developed a nano coated with a titanium dioxide, a nano transistor, you can say that, and memory devices which can working as a memistors, memory and resistance, parallel wires and combinations. A lot of changes are there on a display device. Earlier we had a big size TV. Now that TV that has been reduced because of the flat screen, OLED, and now the QLED is in a line to come up. So now in maybe in a 2 or 3 years we can have a foldable, a plastic kind of the thing, foldable TV and a screen that will be available. That is because of the nanotechnology. The nano mobile also, so no need to have this kind of the gadget. So many of the people can have the mobile of this kind. Now this can be wrapped like a piece of a paper around the wrist, and you can open it out. You can open it like a folded page, clear it, and then that can also use as a computer also. Then lot of research that has been carried out, advancements is carried out in the energy area or energy range, and this energy range that will be developing in a PV cells, PV voltaic photovoltaic devices and cells are there. Then solar cells, lot of discussions on, and lot of discoveries are there. Then in fabrics also, some of the fabrics that has already been there, bulletproof jacket and this and that. Then nanotechnology and sunscreen. Yes, here I would like to tell you that zinc oxide is being mostly used, and titanium dioxides are generally used to prepare sunscreen lotions and this. Nowadays, there is an advertisement on the television. That advertisement says that this particular Fair and Lovely or Imami cream or something, the brands are there. They've been used for the men. Men की आदमियों की अलग है, ladies की अलग है, but it is not something like that. It is not associated with the gender. This is all a funda of earning money. That's it, exploiting customers. But mostly the creams consist of the zinc oxide. Why zinc oxide and titanium dioxides are there? Because you can see over here, whatever the radiations, ultraviolet radiations I'm talking, they are coming, so they've been reflected back, because their wavelength, ultraviolet radiations wavelength, is comparable with the size, so because of that size, their size is very small, and as nano zinc oxide and titanium dioxides are used, so they can be used for the reflection, so they cannot be absorbed by the skin, and therefore you can say that they can give the cooling effect. So these are some of the therapeutic applications. This is what the imaginary picture, a nano robot which can be having a comparable size. As you can see, the size of the red blood cell or white blood cell is something about ranging between 14 to 22 micron meter. Roughly, I am giving an estimate. So the size of this RBC or WBC is something about 14 to 22 or 14 to 18 micron meter, while the size of the nanoparticle is something about in between 1 to 100 nanometer, which is far less, 10 to the power minus 9 and 10 to the power minus 6. So it is been expected that even if some molecular robotics we can prepare, so that they can be inserted inside the bloodstream through the blood carrying vessel, veins and veins, so that the robots can operate by giving the instruction from outside, and that can be done. Hyperthermia is one such applications, wherein these are all the applications. I am skipping some of this. So hyperthermia is something about you can say that by generating a heat inside the body, by inserting the nanomaterial inside the body, we can generate the heat by applying the AC field from outside, and then this kind of the nanomaterial that is being developed, so that is called as the spions, super paramagnetic iron oxide nanoparticles. So that is called as the spions, which has been used, and these are super paramagnetic. But as the time is not there, someday other we can discuss about this thing. So then another application which I was talking about, the phase change material. So what is this phase change? This is a very simple thing that I would like to explain you. As you can consider an example of a water. The water is having one particular temperature, wherein all the three phases of the waters are occurring over there. Number one, a liquid phase. Number two, a solid phase, that is we can call it as the ice. And number three, a gaseous phase. Gas, water, gas, you can, water vapors, you can say that. So wherein we can choose the temperature of the material in such a way that where there can be existing a two phase simultaneously. So that particular concept that has been used in a material, wherein these materials can be used for the phase change material. For example, if you can take a green non-toxic, you can say that the phase change process is a reversible process. Then phase change material is a new type of material that is green environmental friendly. So we can create a environmental friendly materials. We can have the customization kind of the material. I will explain what that material we can say that. So this material, when it absorbs the heat, it can trap the heat and it won't allow the heat to escape. So that from outside, whatever the heat that will be coming to the material, that gets absorbed by the material. So it absorbs and it traps the material, the energy. So that energy which is being absorbed will not be coming out. So therefore, from outside, the material feel like as if it is being cool. So that kind of the thing that will be done. So like in case of clothes, we can make use of the clothes. So these are the phase change material. So wherein they can absorb the heat also, or the other way also, they can release the heat also, what is being trapped. So they, or sometimes they can work as a insulator, thermostatic sleeping bag. So they can work as an insulator, wherein we cannot carry, a mountaineer cannot carry a lot of load on his back. So this kind of the lightweight thermostatic sleeping bags are there, working clothes are there which can dissipate, thermostatic fabrics are there, cold felt towels, and so many cold chain transportation that can be done. So if, for example, you can say that the Vadilal ice cream that has been prepared or that has been made in Mumbai, and from Mumbai, if that Vadilal ice cream has to take to a Gadchiroli area, Gadchiroli district, or a place in the Gadchiroli, or even a place, Maregaon, we can say that for Nilesh, if you want to give a party to all the delegates and participants, those who are in the working committee, you can say that, of this particular organizing committee. So then naturally from Mumbai, if we want to carry the ice cream in a intact way, that is in a cold way, otherwise it gets melted out. We know that ice cream gets melted if it come in contact with the atmosphere. So in that case, we require a lot of energy, so a lot of fuel that will be, because we require the cooling system. But if we use this kind of the paint material, wherein I can show you the paints also. Yeah, this kind of the paint material coating, so that they can protect a thermostatic, or heat ko resist karega. They will not allow any kind of the heat to get penetrated, and the requirement of the storage or the cooling process that will be carried out. So likewise, the batteries are there that can be insulated, and the room wherein the lot of electronics instrumentations are there. Then these are the water heaters also we can be used. Then non-electric insulators, and this, and so many applications of these materials are there. Even interior of the building, wherein in Rajasthan kind of the area, where throughout the year they are receiving a large number of the heat. So that if you coat from outside and inside, nowadays the paints are coming, so they can protect the house. They will keep the house warm, and the energy that will be trapped, that will be protected inside. So likewise, the grounds are there. The nano composite is one such area wherein, so it is already madam, can I take 5 more minutes, or shall I stop?
Yes, sir. Okay, sir. You can continue, sir.
5 minutes?
You can ask 5 minutes or 10 minutes.
Okay,
Very good
thank
lecture,
you.
sir.
Thank you. So nice of you. So nice of you. So because I am going very fast like a Rajdhani Express, I know, because the time constraint is there, and every speaker wants to take more time. So, but I am that way a very gentleman. So that is why I am asking your permission. So the composite is a combination of two or more different materials that are mixed in an effort to blend the best property of both. So we can blend the two materials. Likewise, you can say that the two materials are there. One material is an electric material, a ferroelectric material you can take, and another material you can take as a ferromagnetic material. So if I blend these two material, and if I prepare a composite, then what happened that from a one single unit, from one single material, I can have the electric effect and I can have the magnetic effect. So that is called as the EM effect, electric and magnetic effect, that can be resolved, or that can be solved. So this kind of the materials, composite material, and of course a nano words means a material that can have the small size. The size of the material is in a nano range. So there are different kind of the combinations of the materials are there. Metal combinations you can take here, platinum and ruthenium. These are the taken because they are having some good applications. Then metal and ceramics we can consider. Then we can consider ceramic, zirconia, and like that. Then we can consider some polymer based nanocomposites are there. A lot of research work is carried out in Nagpur, and you can say that in and around Nagpur, then your Amravati University, Nanded University, on a polymer. So we can do that thing also, the polymer and ceramic. So different phases we can take together, inorganic and organic hybrid compositions we can take, and then polymer and then silicates we can take. So with the help of, so what is so unique about this, so increase in the electrical breakdown strength of the polymer. So we can increase the electrical strength, we can increase the melting temperature, we can change the color, we can have the magnetization, we can have the more charging capacity of the material that can be done. And there are so many things are there, a lot of applications of these are there. And here I would like to bring to your attention that many times the researcher from the colleges, few research, and I'm not saying the 100%, they always think that we do not have the advanced technology laboratory, we do not have the facility, we do not have the finance, we do not have the funds to get this and that. So please don't do that kind of the thing, excuses, don't put any kind of the excuses. If a researcher is by heart a hardcore researcher, need not require any laboratory, need not require any much bigger space and much bigger amount. Nowadays the characterizations are easily being done by outsourcing the material. If I prepare a material, because I am preparing a magnetic material, I am outsourcing all the prepared material for the analysis for same, TEM, XRD, VSM, then electric character, all kind of the characterization, FTIR, then what not, Raman spectroscopy, anything you just name it. And those who are having any difficulty, any kind of the problem in the analysis, ask Nilesh Pawar sir, who is the convener of this conference, to contact me. He has my number and phone number, email ID. Definitely he will send to me, and I will tell you that where you can do this property. And of course the cost is also been reduced down. Nowadays I just tell you that, for example, that 10 years back, when I want to do an XRD, so I cannot procure the XRD instrument because the cost is something about 1 crore or 50 lakhs of rupees. So I cannot do that because I am in a graduate college. So but I want to do some research, because that kind of the things are inside me, I want to carry out, pursue research. So that XRD used to cost some 10 years back is about 2000 rupees. Now you can do the XRD, good XRD for a single and polycrystal material in only 200 rupees. You just imagine 10-fold times the price that has been reduced. So why do we purchase a big instrument and maintaining cost 2 lakhs, 3 lakhs, 4 lakhs rupees of maintenance? Why should I spend that? Even I cannot do a XRD of 2 lakhs rupees. So a lot of 100 plus or 1000 XRD I cannot go in a year. So likewise we can do that. So but I appeal to all the people that they should do something or else a kind of the research, so that will develop an attitude of a different kind of the attitude. Even if a teacher, even if the university is not asking you, don't worry, but you can have the happiness, you can have a full kind of the enjoyment when you do something, some good kind of the research. So these are some of the applications of the materials are there, which are the phase change material, abrasion and wear applications. We can avoid the abrasion and wear at the fuel tanks, marine application, food packaging, films, environmental protection, and whatnot and whatnot. So this is one of the applications of the advanced composite. Earlier we used to have an aeroplane, which is a very heavy aeroplane. The size is of course a big size, because they use the metals. They use the metals, and because of that metal, the weight that has been increased. But because of the composite materials, nowadays the composites that has been used and that has reduced, which is having the high strength, the strength is very high, and the lighter in weight. So this is one of the applications, you can say that. So, but I'm just keeping, you can see the advanced composite 50%. So weight of the now advanced aeroplanes that has been reduced down to a 50%, because they are only using 10% of steel primary landing gears. For gears they are using the steels. The titanium, very strengthened materials are there. Then 20% aluminum, which is a metal, but aluminum composites are very strong, so that is been possible. Then these are some of the advanced materials are there. This is the way: metal, single crystal, glass, organic, inorganic, and ceramics. There are a lot of things are there. Ceramics, they have different applications. Then you can say that, just I'm skipping some of the slides because the time is there. So the smart system is there. What is smart system? The system which can have the recording also, and which can sense. Nowadays, the same material which can sense the different kind of the things, different kind of the parameters, that is called as a sensor. Then the same material acts like an actuator. The same material can take the decision like a brain or electronic, and the same material can deliver. So many fold applications, many fold uses of the same materials are there. So they can do simultaneously, so many things are there. So sensor that can gather information, meaning any kind of biological, chemical, magnetic, and etc. The electronic, they can take the decisions also, decision making. And actuators, they are moving, positioning, regulating this and that. So nowadays, the concept of smart home control system that has been appeared, and that is because because of the internet it is possible, and this pandemic has made us to think about the internet. And those who are not using internet nowadays, they have a limited internet access to their home, because from the distance place I can control everything in my home, and that is because of the smart material, and that is because of the advanced material. So therefore I congratulate once again the organizer for arranging the recent advanced material science and nanotechnology, this point of the conference over here. So then there are magnetic material, but I'm skipping this magnetic material because my time. Yeah, one slide I would like to explain you that the development of antennas. We have got a patent on a 5G antenna also. We have developed a 5G antenna that can be inserted inside the body also. And one of the applications of the material is they are the ferrite material. They can be used for the conversion of solar energy into the electrical energy. So earlier the conventional, you can say that the solar panels are using a silicon material, but by addition of the ferrite material into it, a multi-layer, some of the layers that we can add. Earlier it is a silicon only, conventional, but now we have suggested multi-crystalline or multi-layer layers are there, wherein we can use some ferrite materials which can trap the energy, and the efficiency that can be increased down. So these are some of the material slides are there now. But with the advancement of the technology, this is probably the last slide, that in 2009, if you want to take the shooting Chandani, that picture was there, Rishi Kapoor and Sridevi, both are no more, but they have used that this particular technique, that he take the shooting from the helicopter. But nowadays in 2018 or 19, we have the drone camera, where the camera that has been fitted up, and that camera can be controlled from the bottom. And if this way, if we progress for the technology, that a mechanic that has started with this kind of the thing, slowly that has been changed, slowly, and one day the person can be replaced by the robot, and one day the robot will kick us out. So be aware that while doing any kind of the research, or any kind of the you can say that the activity related with the research, we have to think that this human society, human beings are being protected by, whether it is a technology or whether it is any kind of the you can say that the activity, so that it will be a boon for us. Okay, so that will help us, the all human being, to stay intact on this very planet Earth. So it is our responsibility. It is our responsibility of this particular generation to protect the planet. Whatever our ancestors has handed over the condition with this the Earth, we have to hand it over to the next generation in an intact way, so that the next generation can flourish. So, and of course, for that, we definitely need nanotechnology. So thank you very much. Once again, thank you.
Thank you, sir. Thank you, sir. Dr.
Any
Bharti
questions I would
Patil,
like to-
sir, Dr. Bharti Patil has some queries, sir.
Yeah, please.
She wants some question from you.
Yeah, please.
Okay, Dr. Bharti Patil.
Dear participant, you unmute yourself if you have any queries.
Hello, sir. Thank you very much for giving us insight of recent topic, that is nanotechnology.
Yeah,
It
ma'am.
was a very beautiful lecture by you.
It
Sir,
was a
I
running
come to know
commentary. It
that.
was not a lecture. It
Yes,
was a
yes.
commentary.
No,
Yeah.
sir. But your slides are self-explanatory, so
Yeah.
we have understood a lot, and you have given us insight of this present era. So thank you very much for your nice presentation. Sir, my question is that you are having 4 to 5 patents. So will you please give your related work, please?
Yeah.
Brief
Madam,
introduction to your work.
yeah. Actually, we have filed till date 19 patents. Again, I am telling you, I am working in a college, Dr. Ambedkar College, that is in the heart of the Nagpur city. Probably you might have visited the Ambedkar College or the Diksha Bhumi, where adjacent to the Diksha Bhumi. Yeah.
Yes.
Why I'm giving more emphasis that I am working on a undergraduate college. Of course, I have the PG also in my department now. We have started PG some last 6-7 years back. We have research also, but basically my appointment is at an undergraduate level. And still I'm probably Gajanan Moil sir knows me very well. So he is there. Thank you, sir. So see what we are doing. Let me tell you, if 5 minutes are there, I can explain you how we can go for a patent. See, this is what we think, that whatever research we are carrying out should get published through a high impact factor journal. So we are always thinking, because UGC demands a high impact factor journal. But now if you compare an Indian researcher and a researcher from the other countries like a Chinese, 10 years back, Indians and Chinese were on the same platform. When we file a 10 patents, Chinese also used to file a 10 patent. But after 10 years, maybe after 10 years, you can say that the number of patents ratio in comparison with the Chinese, because they are our neighbors and they are our enemies also. So the China, if they file a 5,000 patent, we hardly file 50 patents. So 100-fold times their research that has been increased. So then some of the researcher or some of the brain, you can say that the scientists in India started thinking about that what is that the Chinas are doing, what is it that the country is doing, and why not, where we are failing. So we are failing where we have to change the attitude. A person like me, who is an average student, can file a 19 patents. Then anybody on this earth can do, and any Indian can do that wonder. The only thing, we are not aware about the research. What kind of the thing that we can patent and we cannot patent. Simple thing is there. Whatever problem you are taking for your research, whatever problem you are taking for a research. For example, you are preparing some material for some applications. Okay. Now, then you can search out in a Google that what kind of the materials are there, what kind of the problems are there with that material. कोई मटेरियल के साथ में अगर कोई प्रॉब्लम है, तो you can arrest that problem, you can clear that problem, and you can patent a file. Even a simple, you can you can call me personally. I can give my number
Okay,
also.
sir.
No
Okay,
problem.
thank you, sir.
So I can tell you in more detail. Same
Okay, sir.
research paper, whatever research you are carrying out, whatever research you are carrying out for your PhD or for your PhD student or your colleagues, you can first think about that. What kind of the problem I have arrested out of this research? So our research should not be like that.
Okay, sir.
Somebody has taken x is equal to 0.5, I can take x is equal to 0.75. No, don't do that. So you do that.
Okay,
This
okay.
particular problem, how can I solve with my research? And then you file a patent. Today you can file a patent, and next day
Okay.
you can put the paper on that. So you can put your research paper
Okay.
next day, previous day. So you can have the simultaneously patent also, and you can have simultaneously a research paper also. Very simple way
Okay,
you can
okay,
go.
okay.
So this is how
Thank
you
you very
can
much,
go
sir.
for the patents. And there are
Okay.
patent agents are also there. In
Okay.
Amravati, one agent is there through which we have done this work. Now we have in
Okay.
Nagpur also lot of agents are there. They can tell you. Or
Okay,
more
okay. Thank
details
you very much, sir.
I can tell you.
Okay, thank you very much, sir, for nice information. Thank you very much.
Thank you, sir. Thank you, sir. Dr. Revatkar, sir, delivered a very nice lecture on scientific challenge and achievement in 21st century or perspectives. A very, very interesting lecture, sir. It itself, this lecture shows how you got or you are awarded with the best teacher award by RTM University. While presentation, we have seen your dedicated. We have seen that you how you are dedicated for teaching, and we have also seen one of the energetic person. Thank you, sir. You have focus on various applications of the nanotechnology and nanoparticle and its application, and these applications are related with the routine life. You have taken various examples which we generally use in the routine life, like that of Fair and Lovely, Imami, or we have taken, you have also focused on the greenhouse gases emission, and you also focus on the global warming and climate changes. You have taken a very, very simple example in your presentation. It is very, very interesting, sir. You have the source of inspiration for various researchers, sir, and therefore I would like to thank you, sir, very much from the bottom of my heart. And this presentation is very informative and useful for all the researchers and the students also. Thank you, sir. We are very lucky that we share your experience and your research with us. On behalf of the organizer and all the participant, lucky participant, I would like to thank you, sir, once again.
Thank you, ma'am. Thank you. Thank you.
Now move on the another invited talk, which is delivered by Dr. Gigi More. He is professor and head of the Department of the Physics, Sant Gadge Baba, Amravati University, Amravati. May I request Dr. Bijwe, sir, for virtual welcome of Dr. Gigi More, sir. Thank you, sir.
Moe sir, please show your memento and the certificate, sir.
Okay, sir.
Yes, sir.
Here I have issued earlier from Vijay sir.
Thank you, sir. Now I would like to hand over this.
Appreciation, sir. Thank you, sir.
He is going to
hand over this for your presentation, sir.
He is going to handle the next session. That's why he left early. Okay. So. Okay, very good morning to the organizing committee members, resource persons, and all dear participants. Today I am going to talk on the evanescent wave-based fiber optic intrinsic biosensors. So in this my talk, firstly I will just give the introduction about the sensors and fiber optic base biosensors. Then I will talk about the experimental techniques regarding design and fabrication of the sensors and our results. My group studied on this glucose biosensors. I will present those results in front of you. So every living being is blessed with some kinds of sensors. And these animals or human beings have the senses, sense of hearing, sense of uh, sight, or to detect light, sense of taste, sense of touch or heat, and sense of smell. So we have five organs to sense these things, natural organs. But in the modern era, we cannot rely on this only these five senses, five kind of sense organs. So we have to widen the sense horizon and we require different kinds of sensors to detect different things. Okay, so there are people are now going to develop different kinds of artificial sensors and biosensors. Okay, so this sensor maybe physical sensors, chemical sensors, or biosensors. So physical sensor detects some physical changes, chemical sensor detects chemical changes, and biosensor detects a biological entity, biological element. Okay, so in the biosensors, there is a reaction between analyte and bioreceptors, which brings chemical or physical changes, release heat, or flow of electrons, or change in pH, or the masses. By detecting that, we can talk about the particular analyte is there. Analyte is there in that some. In that particular proportion, and we can detect its presence and the amount or the concentration. Okay, so the why these biosensors are so important? So the it is required because in if you consider the in case of the diseases, for example, cancer, diabetes, and other things. So we need to detect these things in earlier stage to avoid the some difficulties in later stages. So, okay, so because in later stages the cost of the treatment and other things it will be very large. So we, if you detect the diseases and the element or the constituents which are bringing this disease to us, so we can take up the precautions earlier. Okay, so that the cost of these expenses regarding the healthcare we can reduce. So these biosensors can be used in a medicine, agriculture, processing, pharmacy, pollution monitoring, food, in food industries, biological warfare, hygiene, environmental, or forensic and forensic industries. Okay, so in so many places the biosensors are required and there are modifications day to day is going on to develop the more it is a portable, simple and compact. It is a small size and easy to interface and integrate with the signal processing device. So these kinds of the biosensor we require, which has a high selectivity, sensitivity, and stability, and it can be used in situ monitoring. Okay, so the biosensor is an analytical device which has a biological recognition element which is directly interface to the signal transducer, and we can that transducer convert that signal into the measurable response or measurable observable signal. Okay, so we can have the general design of the biosensor of this kind, For example, we have to detect some analyte. Some analyte is here, targeted analyte is here. So, considering the targeted analyte, we have to consider a biomolecule, that is a receptor molecule, receptor element. Okay, so it has a receptor element. It may be enzyme, antibody, nucleic acid, cells, aptamers. Okay, and these biomolecules we have to just deposit on a certain kind of matrix. This matrix will help to protect, bind these biomolecules for a long duration and protect them. So these may be, it may be include polymers, graphene, nanoparticles, carbon nanotubes, gold nanoparticles. So these things will increase the sensitivity and stability of those biomolecules, and we can detect the analyte very easily. So here this analyte and biomolecule react to produce a certain signal, certain changes. It may be electrochemical, optical, piezoelectric, colorimetric, and these signals convert into the observable signals. So we require that a transducer. So transducer convert that whatever the changes made by the analyte with biometrics biomolecule into the observable signals. So it may be it can be displayed in numericals or in a graphical manner or in image manner. So we can this transducer convert that signal and it is sent to the signal processing unit, and it will be displayed to you in the numbers or in a graphs. Okay, so this is the general design of optical biosensor. Okay, depending on the transducer and receptors used in the designing of the biosensors, we can classify biosensors this way. So if you consider the transducers, on the basis of the transducer, we can classify these biosensors into electrochemical, piezoelectric, optical, calorimetric, and conductometric biosensor. The electrochemical biosensors may be classified into this amperometric, potentiometric, or voltmetric biosensors. Pardon? I am emphasizing on the optical biosensor as I am talking about the fiber optic based even you say wave based optical biosensors. So these optical biosensors again it can be of this kind of absorbance. It may use the absorbance, fluorescence, microbending, modified cladding, bragg rating. So these optical biosensors can be classified depending on which types of whether absorbance you are measuring, fluorescence is measuring. So there is a use of macro bending, or cladding is modified, or there is insertion of bragg rating in the sensing element. And depending on these bioreceptors, we can use the enzyme, antibody, nucleic acid, cells, and biomimetic. Okay, so cells may be this microorganism, tissues. Okay, so depending on the transducer and bioreceptors, we can again differentiate these biosensors. So biosensors may be catalytic biosensors or affinity biosensors. In catalytic biosensor, enzyme and microbiological cells are used, which catalyzes that bioreaction, that reaction, and produces a change in that solution or in that environment. Affinity biosensor includes the antibodies, nucleic acid, lectins, and hormone receptors. These are used to recognize that analyte, which it is, and it is non-catalytically. It is non-catalytically. Okay, so we have to immobilize this bioreceptors over this matrix and matrix or substrate. So in that case, it may be you can directly add so that enzyme or that biomolecule it may attach to the substrate through the absorption, or it may form a covalent bonding. So sometimes it is not getting absorbed or forming covalent bond, so we require this matrix entrapment or encapsulation or cross linking with certain other agent. So in our study, we have studied the detection. We have studied the detection of glucose in the solution. So in the glucose, certainly we have used glucose oxidase. It is an enzyme which oxidizes the glucose to the in solution. It oxidizes glucose in the presence of oxygen, air oxygen, into gluconolactone, and this is hydrogen peroxide H2O2. So in this one, this enzyme, the analyte get attached to that enzyme and get it is dissociated to form the product. So in this case, this glucose it oxidizes in the presence of glucose oxidase to form the gluconolactone plus hydrogen peroxide H2O2. So, what is the need of this glucose biosensor? As it is predicted that it is in 2030s. So every fifth person it will be a diabetic one in India. Okay, so this diabetes it is increasing very rapidly because of this our day-to-day life and this our this eating habits. Because of that, this diabetes it is increasing day by day. So there, because of this diabetes, major healthcare problems it may be increased with a lot of complications, which leads to the increase in the morbidity and mortality. So in addition, diabetes is linked to much with the heart diseases and strokes. Stroke. So this is a dangerous disease. It is caused due to the unbalance of the sugar in blood. So we have to check that sugar. So first glucose biosensor was it is developed by the Clark in 1956, and then it was again modified depending on based on the electrochemical analysis. It is developed in 1962. So after that, so many kinds of glucose biosensors have been developed, and it is again the modifications are going on. It is this is a continuous process and it is going on. So it is quickly we shall see the optical optical fiber sensor components. So these optical fiber based sensors, how this we require this light source at the input, then optical fiber, and then transducer, and detector, and then processing unit. So you can have this block diagram of this optical fiber based biosensor sensor. It is a source, then optical fiber measurement, this is transducer, detector, and electronic processing unit. Okay. So depending on the use of the optical fiber, we can distinguish this optical biosensor into two groups. It is extrinsic fiber optic sensor and intrinsic fiber optic sensor. So in extrinsic fiber optic sensor, the use of the optical fiber is just to transport the light from the source to the position or the region where which we are detecting the analyte. And then collect the signal from that the region of the reaction to the processing unit. Okay, and in intrinsic fiber optic sensor, the fiber optic the optical fiber plays role in detecting, it has an active element, so which plays a role in detecting the analyte. So the intrinsic, in extrinsic fiber optic, this optical fiber is just playing role of transmitting the signal from the source to the analyte, and then from the after that reaction from analyte to the your processing unit. And in intrinsic fiber optic sensor, this optical fiber it is playing a active role in detecting the analyte. So intrinsic fiber optic sensor we can again have these different kinds. The fiber refractometer, luminescent spectroscopic based intrinsic fiber optic sensor. Again we can have the coating base and core base. This fiber optic based sensor we can again have operate in different conditions. So we can measure the transmission, reflection, and micro bending. So again, this fiber optic sensor, it may be interferometric optical sensor, depending on depending on the modulation technique. We can consider we can detect the change in the intensity. We can detect the change in phase, polarization, and the wavelength change in the wavelength. Okay. So the intrinsic, this is extrinsic optical fiber-based sensor. So this extrinsic fiber optic sensor, in which this optical fiber just it is it is has the transferring this light from this source to the sensing region, and then after it is collecting the signal from after sensing to the detector, to the detector. But in intrinsic fiber optic sensor, this optical fiber has the sensing element, sensing region engraved on this optical fiber. So this, in this case, the optical fiber it is playing active role in the detecting the analyte. So we know the optical fiber it has a core cladding, and then outer part is a upper coating. So for the protection of the optical fibers. So this core and cladding, these are the active constituents of the optical fiber. So core has the refractive index greater than the cladding. So the light is transmitted through the optical fiber because of the total internal reflection. So this light it propagates through the optical fiber because of total internal reflection as this light passes from denser medium to rarer medium. So this core has the refractive index greater than the cladding. Now we can insert, we can allow to pass the light from one end. So there is an acceptance angle, acceptance cone through which we can pass the light into the couple the light to the optical fiber. So here is core and this is cladding. So this light is passing through this optical fiber. So it is at the interface of this core and cladding. Light is getting reflected back as it is satisfying that condition. It is so it is getting reflected back. So there is a total internal reflection. So the at the interface it is getting reflected back, but the field, we can say the field should be zero in the core cladding region, and the electric field, the field of that electromagnetic radiations light, it is present in the core, but it is not the case. Some electric field, that the field it leaks inside this core, it penetrates the cladding. So we say that field is evanescent field. Some portion it is passed through the core, it moves out of that cladding. So we say it is a leaky modes or leaky radiations, and other radiations rays or light transmit, it passes propagates through the cladding. Okay. So this UNE center wave we require, as we have already seen that UNE center wave, it is a, this is core and this is a cladding. So this even there are some leaks. It is passes or it is present in the cladding region. And if you remove this cladding, and it is replaced with the active element. Is as if you deposit over this, removing some region of this cladding and depositing polymer matrix and then attaching bioreceptor to that one. So this cladding is modified and it will have different properties as it comes into the contact with the analyte. So again, there will be some changes in that region, and because of that, it is developing changes in that region. So there will be a change in the intensity or wavelength of or the phase of the light passing through this optical fiber. So we can detect that changes at the output, and we can calibrate the that sensor to have so we can detect the that changes to talk about the concentration of that analyte present in that solution or in that region. So optical fiber, know the there is single mode step index optical fiber, multi-mode step index, and multi-mode gradient index optical fibers. So single mode optical fiber allow only to excite only one mode. Multi-mode optical fiber, you can excite different modes in the optical fibers. In the optical fiber. Okay, so yeah, this cladding modified intrinsic optical biosensor will have this kind of arrangement. This the cladding is modified with the polymer matrix and the that is bioelement receptor molecule is attached to this cladding, and this cladding is modified. So this biorecognition element, in our case, in the detection of the glucose, biorecognition element was a glucose oxidase enzyme. Glucose oxidase enzyme, and it was deposited on this cladding. So cladding, after removing the cladding, it was deposited on the core. So the cladding was modified, and this source, the light is passed through that core, and it is detected at the output. So in the this designing, we require to remove the firstly the cladding, then tapering that core little bit. In order to bend that one, we can have the micro bending or do bending to increase the ionisant field, and then we can have this type of the sensing element. So we can operate the sensing element depending on the refractive index of the modified cladding. So we can have the ionisant mode, leaking mode, or partially leaking mode. So the advantages of this kinds of optical fiber sensor includes it has a small size, it is miniaturized size, and it can be used in vivo. This is operation. It can be operated in hostile and hazardous environment because we don't need to go there. So we can just insert that element in that environment. In this case, we don't need to have the reference electrode. Again, it is the electromagnetic interference is less in this case. It is low detection limit is very it is a very low detection limit, so it is a very sensitive kind of sensors. So it is highly stable with respect to the calibrated one, and it can detect more than one analyte simultaneously. So, and it is also able to detect measure the non-polar molecules. And it is lightweight, portable. So this kind, it has so many advantages, but at the same time it has few disadvantages. So it only works when appropriate reagent can be developed, subjected to ambient light interference, so we require that much of darkness. So ambient light should not be there. In some cases, the response time it will be high, so it is a little bit slow. And again, we require the immobilization. That is, immobilization is again little bit tricky one in this case. So we have to immobilize the bioreceptor on that core, and it affects because it is possibility that it gets leached as you are seeing with the using in the solution in which the analyte is present. So it may affect the sensitivity and stability. So and again, the sources, detectors, and specific kinds of specific types of fibers are not easily available. Now they are available, but it is not easily available. So it is these are few disadvantages of these kinds of optical fiber based biosensors. Okay, so this fiber optic base biosensors can be used in clinics, agriculture, in biomedical application, environmental application, in food processing. So, and another area also we can use the optical fiber based biosensor. So, in our study, we have used the polyaniline polymer because it is very easily available and it is easily available and can be easily polymerized. So and it is well studied polymer. So we have used in our study this polyaniline polymer to have the coating over the core. So the experimental arrangement we have used here is the deuterium halogen lamp. So we have also replaced this with laser in some study. This is the measuring cell, which consists of this sensing element. And in spectrometer, or in some cases, we have used a CCD camera beam profiler to study the modal power distribution. Okay, so we have designed very simple this sensing cell. This is the sensing cell in which this cladding modified optical fiber element. So we can easily prepare this sensing element. Firstly, we have to remove the cladding of that optical fiber of around 1 centimeter, and then this clean, then temper, and then deposit the polymer over that one, and then we use that one. So in our cases, we have used this silica for plastic clad optical fiber of a diameter 750 micrometer. So and the cladding was modified directly by inserting that removed this cladding removed portion in that this conical parts during the polymerization. So in this case, the polymerization during polymerization, that's an element to of which you have to modify the cladding. It was inserted in the that conical parts, and during polymerization, the thin layer of the polymers deposited on the optical fiber that pore of a modified cladding. So this is this picture of this is the before cladding. This is a picture of before modifying the cladding, and this is the picture after modifying cladding. So this picture shows the modified cladding. So there is deposition of the polymer on this optical this core. Okay, so we have prepared the test solution. We have performed all these experiments in the buffer solution of phosphate buffer solution of pH 7.4. The all other glucose solution and glucose oxidase solution were prepared in phosphate buffer and with a pH 7.4. And then we have immobilized this glucose oxidase enzyme over the deposited polymer matrix via cross-linking with glutaraldehyde. Okay. And we have used, we have did the as usual studies, visible spectroscopy, then Fourier transform spectroscopy, X-ray diffraction, and other things. And we have used this beam profiler, CCD camera beam profiler to study the modal power distribution and measuring the total power at the output. So in the preliminary study, first study, we have used polyaniline matrix, then sulfuric acid dope polyaniline, oxalic acid, and boric acid dope polyaniline, and we have studied the response toward the analyte. So this shows the visible spectra of the polyaniline dope with sulfuric acid, oxalic acid, and boric acid. Okay, so this pure polyaniline shows the peak at around 278 and 278 nanometer. Okay, so FTR study. So these are the same images after depositing or after modifying the cladding of the optical fiber. So this is the sensing response by measuring intensity. So in the input we have used the HNA laser, and at the output we have just measured the power. So this shows the variation of power with time. This first this A curve A, it is showing for a phosphate buffer. So there is almost there is no change in power. This B, it is for this is for the response for the 10 nanomolar glucose solution, and you will see there is a response. This firstly the power at the output, it is increasing, and then it gets stabilized. It gets the saturated power at around 180 seconds. That is approximately after 3 minutes, and it becomes a constant one. And as the concentration of this glucose in solution increases, so the optical power at the output, it is increases. And we have calibrated that. We have just fitted this plotted this increase in the power at output power with the concentration. So we got this exponential associated fit for that result. This is the response for sensing response for sulfuric acid dope polyaniline modified cladding. So here again we are getting the same response, and it is fitted into the exponential associated fit. This is showing the sensing response for the polyamine dope with oxalic acid. We are getting again the sensing response for this one. This is sensing response measured for the polyaniline dope with boric acid. Okay. In these cases, we have used the HNA laser in the input and measured just output at the we have measured at power at the output. In another study, we have use the input HNA laser, excited these modes in the optical fiber, and we have studied the modal power distribution with the concentration. So here, if you see, this is the first one. It is for 1 millimolar solution. So this is modal power distribution, and in the inner mode the intensity is more, and at the outer this intensity is less. So as the concentration of glucose it is increased in this solution, The outer intensity of the outer mode, it is pushed in the inner mode. So the intensity is going on increasing, and this outer mode, these are diminishing. So we have seen the intensity of the inner mode is increasing. So the again the output power it is increases. So the intensity of the inner mode it is increasing. So this way we have studied the variation in modal power distribution. This is the modal power distribution study of this polyaniline doped with sulfuric acid. This is the polyaniline doped with oxalic acid. So here again we are getting the same kind of nature. So the power distribution, it is the power in the inner mode, it is going on increasing with the concentration of glucose in the solution. So this is the model power distribution study for boric acid doped in polyaniline. In another study, we have just studied the variation in the absorption at a particular frequency. So at the input, we have attached the helium, hydrogen, that is deuterium lamp, and at the output, we have attached fiber optic based spectrophotometer, and we have studied the absorption at the wavelength 272 nanometer. So in this case, it is observed that there is a variation in the absorption at 272 nanometer. At 272 nanometer, and we have considered that absorption at that position, and we have seen plotted that curve, and it is again showing the same kind of nature. It is fitting to the function exponential associate function. So this is for the polyaniline doped with sulfuric acid. We have measured the absorption at 255 nanometer, and we have studied the response of that one. For the oxalic acid doped polyaniline, we have measured the response at 259 nanometer. And the boric acid doped polyaniline, we have studied the response at 263 nanometer. Okay. We have also performed the stability study over 50 days. So every day we have studied the response of that sensor. So this black line, it is for the pure aniline, it is showing a black one, it is constant up to 35 days and then it degrades. For this other sulfuric acid, boric acid, oxalic acid, doped polyaniline, it is showing high sensitivity, but the stability goes on decreasing with as time passes. So we have studied this stability for these biosensors. Again, we have studied the percentage decrease in sensitivity for stability. So it is derived, it is estimated from this formula. It is R0 minus R1 upon R0 into 100. So this R0 is the response at the start of the interval, and R1 is the response at the end of that interval. So we have studied consider these intervals 0 to 10, 10 to 20, and 20 to 30, and 30 to 40 days. And we have seen this decrease in sensitivity. It is very small for the pure polyaniline, and it is maximum for boric acid polyaniline. So this is the decrease in sensitivity. We have also studied the selectivity of these sensors. We have used, as in a blood or in urine, there may be so many interfering constituents. So we have to check whether the developed sensor is selective for that particular analyte or not. So here we have used glucose, fructose, sucrose, ascorbic acid, lactic acid, urea. So these interfering agents we have used in solution. We have separately studied the response of our optical biosensor to this one, and we have seen the response. This is for fructose, and this is for the glucose. So certainly the sensor showing selectivity toward only glucose, as we are using glucose oxidase as an enzyme. So from this study, we can say that we can measure, we can study, or we can detect the glucose by modifying the cladding of optical fiber, and we can attain. In our case, we have attained the lowest limit of the glucose in solution. It is 10 nanomolar by both the technique measuring the modal power distribution and the variation in intensity at the output. Okay. In another study, we have modified the cladding with polyaniline ZNO nanoparticle nanocomposite, polyaniline TiO2 nanocomposite, and zirconium oxide nanocomposite. And we have studied again the same thing, same study we have performed over this one. So this is the visible absorption study of those polymer nanocomposite. So these are the same images of that modified cladding. This is the sensing response for polyaniline zinc oxide nanocomposite modified cladding modified fiber optic intrinsic glucose biosensor. So here we are getting the stability, we are getting the response time at around 150 seconds. So after approximately 3 minutes, we are getting the saturated signal, and it is becoming flat as time passes. Okay, and the response, it is going on increasing with the as concentration increases. Okay. This is the sensing response for polyaniline TiO2 nanocomposite cladding modified FOIZB. This is the sensing response for polyaniline zirconium oxide. And these are the modal power distribution we have studied for all this polyaniline zinc oxide, polyaniline TiO2, or polyaniline ZrO2 nanocomposites. Okay. Again, we have seen the same trend as the concentration of glucose increases in the solution. The outer mode, it is reflected back inside your optical fiber, and the intensity
Sorry for
in the
interruption, sir. Sir, sorry for interruption. Due to tight schedule, can you conclude in few minutes?
Okay, madam. Within 2-3 minutes, I will conclude.
Okay.
Okay.
Thank you.
So we have then studied this absorbance of this absorbance study to measure the response of this optical fiber for this polyaniline zinc oxide nanocomposite PTiO2 zinc oxide PTiO2 nanocomposite and PZrO2 nanocomposite. Okay, so we have again studied this stability over 50 around 45 days for this in this case. Again, we have measured the selectivity, sensitivity, and then selectivity. So from this one, it is again in this case also we have found that the optical biosensor has the lowest detection limit around 10 nanomolar, and although sensitivity is high, but the stability is very less. It is reduced one, and it is within 25 to 35 days. Okay. So in another study, we have used the serious nanoparticles, graphene, and carbon nanoparticles to modify this cladding and study this response. Okay. So this way we can use the optical fiber for the detection of this glucose, and in another study we have used urea we have used this same kind of sensor, but only the enzyme is changed, and we have detected urea also in urine. Urea. Okay, so urea biosensor we have also developed, and we have presented these results in reputed journals. Okay. So this is about the optical fiber based luminescent wave based optical fiber biosensors to detect glucose, and then we can use this for same thing for the urine. So thank you. I acknowledge this is whatever the work I have presented. It is of my student Dr. Vikas Porukar. So I acknowledge his work. Thank you. If you have any question, any query, you can ask. Please.
Participant, unmute yourself. You may ask your queries. Dear participant,
One question
unmute
from
yourself and you may ask your queries.
the Vaishali Deshmukh. How can we calculate the biosensing response?
We have just compared the response with as we have made the solution of this analyte in phosphate buffer. So we have just compared the response with the pure phosphate buffer and considering having that particular amount of analyte in that phosphate buffer. So we have compared these two responses.
Thank you, sir.
Hello. Hello, sir. Sir. Hello. Sir, myself Bharti Patil. I wish to ask, as the refractive indices of the N1 and N2, that is core and cladding, are very much similar, then how to determine their difference in refractive indices?
So, madam, in this case, we have not measured the refractive indices. We have just modified cladding, and then we have seen how the intensity at the output changes in a modal power distribution at a particular wavelength or total power. So we have just made, so certainly there will be changes in the refractive index as there is a reaction is taking place at the modified cladding portion. So because of that, the output intensity, the modal power distribution, and the absorption at a particular wavelength.
Okay, thank you, sir. Thank you, sir. Thank you.
Yes, sir. Thank you, sir. Mole sir delivered a very good and very informative lecture on the advances in event sensors waves based on fiber optic and intrinsic biosensor. He explained in detail importance of the biosensor classification based enzyme based sensor, need of glucose biosensor, classification of the fiber optics and advantages and disadvantages, and very good lecture, sir. It is really informative and knowledgeable lecture and very informative discussion also. Thank you very much, sir, for your thought provoking talk on behalf of the organizers.
Thank you, thank you, organizer for giving me this chance to present my to work of our group here. Thank you all.
Thank you, sir. Now this is the time for final invited talk. And the speaker of this talk is Dr. Ritesh Kohle, sir. He is Department of he is from the Department of Physics and he is the head of the department Sant Gadge Baba Mahavidyalay Hingna Nagpur. He is 10-year experience, teaching experience. He published more than 35 research paper in national and international journals. He is an author of one book of Elsewhere, one textbook, one editor of one book. He is a member of various professional organizations, including editorial board of American Journal of Optics and Photonics. He is a reviewer of the international journal, including Elsewhere publication. He visited Greece, China, Hong Kong for his research and educational purpose. Now I request Dr. N.R. Pawar, sir, convener of this conference, for virtual welcome.
Welcome, sir. Kohle, sir.
Thank you very much. Thank you very much. It's my pleasure,
Sir,
and
you are
I'm
most
very much
welcome.
delighted.
It's a small token of love and appreciation, sir.
Thank you so much for kind appreciation.
Yes, sir. Thank you, sir. Bye, sir.
With this kind appreciation, may I request Dr. Ritesh Kohle, sir, to deliver his talk. Dr. Ritesh
So,
Kohli, sir.
is my screen is visible to all of you?
Yes.
Thank you very much, madam, for this nice introduction. And let me first congratulate Professor Dr. Pawar sir for organizing such a wonderful conference in a very sincere and perfect manner. So I am also part of this conference. So it's my pleasure to have been asked to propose my talk in this conference. So myself, Dr. Ritesh Kohli, I'm working as an assistant professor and head department of physics at Maharaj Mahavidyalaya. So today's my talk is multicolored and white light pyrophosphates for eco-friendly lighting applications. So before proceeding, let me have interaction with all of you, as most of the conference delegates and resource person are from luminescence background who are working in the field of phosphor materials for applications since long ago, since years before. So basically, what we are trying to do in our labs and in our research is to prepare phosphor materials for solid state lighting and LED applications, which is the fundamental requirement of this recent era. So we have tried to prepare such materials that are eco-friendly and that are cost efficient for lighting applications. So we will proceed to these overview. So introduction about phosphor materials, sample preparations, then characterizations of these materials, and the applications of these materials. So before starting my talk, let me how is getting dangerous to the environment nowadays. So these screenshots of some newspapers and tell us very clearly that how the compact fluorescent lamps are really dangerous to the environment. Not only because of the disposal problem, but the mercury content inside that CFL lamps are becoming a dangerous issue for our environment. So you can see the newspapers that daily pushing for eco-friendly, energy efficient LED bulbs. There is mercury in those CFLs, and this we can lead to the repair the materials are non-toxic materials for lighting applications. So are the compact fluorescent bulbs are really dangerous? So yes, it is really dangerous because the fundamental problem is that the improper disposal and recycling of CFL, it is getting very serious issue nowadays. As you can see, nobody is curious about that how to dispose the waste CFL lamps from our household industries. We easily throw it anywhere, and we don't think about that how much of mercury is going to harm our environment. So this is a very serious issue, apart from the other issues that how to dispose it. And so can't we think that to prepare such kind of materials, such kind of lighting materials that doesn't contain mercury, which are non-toxic. So we are thinking in that direction, and we are consistently working. My mentor, Dr. Ajay Doble, is consistently trying to prepare such materials which are non-toxic, which are cost efficient, which are eco-friendly, and his work is tremendous in this regard, and we are following his path. So this warning tells us everything, that CFL bulb emits mercury when it is broken, and you can see here. So pregnant women should not eat but so this issue is becoming very serious nowadays. So here we will try to concentrate, we will try to prepare such material because this lamps are used by business and institutions in the rural areas. So if you think at your personal level that how much it is going to cost me if I throw the mercury containing bulb in the atmosphere or environment, so how much it is going to going to cost, if you recycle them as a universal waste, so it is going to cost you somewhat. If you dispose them as a hazardous waste, it is going to cost you more because it's a issue of environment. And if you get caught breaking law illegally disposing of this hazardous waste, it will cost you a lot more. So it's time to think over these things. Now, effects of mercury on the environment, you can see these pictures, you can see the seriousness of this mercury content light. So 1 teaspoon of mercury can contaminate your entire 20 acre lake. 1 teaspoon of mercury. An estimated 600 million fluorescent lamps are disposed of in US landfill, so amounting 30,000 pounds of mercury waste. Right. So it is going to cost you a lot more if you use these kinds of lamps. So these are the great challenges for 21st century, that can we make such materials? Can we make such materials? Excuse me, sir. Is my screen is visible to all of you? Hello.
Yes, sir.
Yes, sir.
Is my screen is visible to all of you? Because
Yes, yes, sir.
Yes, sir.
Yes, sir.
Okay.
Continue.
So it is going to cost us a lot. So can we make such materials for lighting which have the following properties, that are low cost synthesis, non-toxic, and it must have the chemical and thermal stability, eco-friendly and economic. That is our fundamental issue. And it's decade that is used for prepared phosphor materials, that what is the lifetime of that material, and brightness and efficiency. So the answer is yes. Yes, we can prepare such type of materials that are non-toxic and low cost synthesis. So RGB phosphors are for LED and solid state lighting is one of the greater channel to get into that process. Hello.
Yes, sir. Sir, you are not audible. Kone, sir. Hello.
Hello.
You are not audible, sir.
Hello. Right now?
Yes, right.
Am I audible now?
Yeah, yes, sir.
Hello. Okay, thank you, sir. Hello. Hello. Hello.
Sir.
Hello.
Yes, sir. Hello.
So why we use these LEDs? There are some issues as compared to the and it is economically affordable for everyone, but still in the rural areas people cannot afford these LED lamps because of just cost is quite higher, and it's versatile, its lifetime is more. So comparatively, when we think about the LED lamp, incandescent lamp, and CF, so it is very affordable in every sense. If you think for average bulb light, if you see cost per bulb for your household and industrial applications, an average cost you can see it is affordable as compared to CFL and Intel. So only requirement for these materials that phosphor materials which is containing inside your LED lamps that should be cost efficient for manufacturing, mercury free excitation and eco-friendly characteristics. So in our labs we try to prepare such kind of materials. So and particularly we focused on the pyrophosphates.
Ma'am, please send your queries on my WhatsApp, yeah, on my email address, sir. Okay. Okay.
Hello.
Hi, sir.
Hello.
Yes, sir. You are
So
audible.
we are preparing the pyrophosphate materials that contains the oxyanions or phosphorus. I will not go in details of these phosphate, particularly pyrophosphates. As we are running quite late, I will particularly focus on the materials which we have prepared in our lab. So oxygen, that is P2 58 to 1.64 angstroms. So what are pyrophosphates? Basically, they were originally prepared by heating phosphates at very high temperature, and the word pyro comes from Greek. That means, so why are using these kinds of material for applications, and so that's unique factors here. It gives you the emission in that particular region for RGB phosphorus. So the chemical durability is very high as compared to other phosphate materials because it is prepared at very high temperature. It has high thermal stability, low cost, of course, what is our main motive. And they have these specific technological applications that we will see in next months. Phosphates is the first member of an entire series of polyphosphates. They have many uses in industrial chemistry. They are good complexing agents and highest solubilities among the all phosphates. That's why I chose this material. So we tried different synthesis techniques depending upon our requirement for preparing these kinds of materials. So solid state diffusion is one of the most kinds of materials, pyrophosphate materials. Other, we have tried the combustion synthesis at our lab. These are actual pictures of prepared phosphor materials in the laboratory. Sol gel method we can try, but there is an issue of solubility of carbonates or oxides are not water soluble. So that is why we prefer these two techniques to prepare solid state diffusion and combustion synthesis. And these are the fundamental characterization techniques that require to, to, to bring that material on that platform that it is useful for solid state lighting and LED applications. So XRD for structural characterization, same for morphological investigations. For structural and molecular bonding, we have tried Fourier transform and PL spectroscopic study for the applications in this. The synthesis technique is very familiar to all of you, those who are working in this and in the chemistry. So starting material weighing in the stoichiometric ratio, direct mixing at stoichiometric ratio, fired at desired temperature, crush and get a homogeneous mixture and then use for characterization purpose. So this is the example with the standard PDF file number 0070152. So it confirms the material for further applications. Same, it reveals that the it is prepared at 700 degrees Celsius and particle growth took place quickly, and the average crystallized size is sub-micrometer range. The sample prepared at 700 degrees Celsius shows 900 nanometer particles size so which is applicable in powder form for coating purpose in LED lamps. This is a spectroscopic investigation, photoluminescence spectra. Then this material is at 395 nanometers, which is uh, between 300 to 400 nanometers due to the FF transitions. So this is due to the crystal splitting of this material. And emission peak you can observe here that 595, that is in the yellow region, and 604, 14, that is in the red region of visible. So, its intensity of these bands depends upon the host. So this may be one of the potential candidate for RGB phosphor. So this is another material that we prepared is zinc pyrophosphate. The emission at 482 nanometers and 575, which is in the blue and yellow region of the visible spectrum. So these are the energy level transitions what we did in the spectroscopic investigations for dysprosium and europium. Fourier transform in spectra is the structural and molecular environment of this pyrophosphate material. So, so many materials we prepared in this regard for checking their applicability in this field. So, the chromatic properties, it is revealed that this emission wavelength lies in the show of the color rendering index figure you can see here. So, it is indicated in these colors that it can give you the emission in blue color, it can give you the emission in orange, red, deep red. So in the view of broad excitation and luminescent properties, the zinc pyrophosphate is expected to be a potential candidate for application in UV white light LEDs and solid state lighting because of its cost efficient manufacturing, mercury free excitation. As you see earlier, 395 and 351, it is the mercury free excitation because up to 254 nanometers you need the mercury, but beyond that, that is 395 nanometer and 351 nanometer, it is totally mercury free excitation. So that's why it can be used as a eco-friendly material for lighting applications. So these are some reported multicolor phosphors that are prepared in our lab, and most of the work is reported in renowned journals. This is the first material that we prepare, SRCA-P207, doped with europium, and we go the of our work. This is the broadband excitation and single color emission in the blue region of the visible spectrum. So these are other materials that we prepare, K2MGB207 and SR2P207. So all these materials are, this is green emission efficiently in this material. Reported work in labs. So most of the work is published, and still we are trying to prepare the materials. This is the list of materials, especially particularly focused on pyrophosphates that are useful for the solid state lighting and LED applications. Different synthesis techniques, we mentioned that what synthesis technique is appropriate for what material, and these are the excitation wavelengths of that particular material that we studied, and these are the emissions they are getting from it material. And this entire book is published in these two particular books. This is from elsewhere, and this is from Nova Science Publications. Closer look at pyrophosphate. So you get the thorough information of these materials in these two books. Recently, we have published it with Professor H. Doble and my colleague Dr. Vijay Pavade. So the detailed information regarding these pyrophosphate materials we will get in these books. So these are some applications of these materials that we can see. It may be used for afterglow applications, white LEDs, automotive lightings, laser crystals, scintillators, we can use it as a scintillator. So these phosphor materials can be used in these areas of lighting and scintillating applications. So with this, I conclude my talk because we are running quite late. That's why I sum up it in a short span of time. So thank you, and let us partner and banish the kerosene and tungsten lamps from the homes of our poor people and provide them at least the best possible light for 12 hours a day and 365 days a year. So this is our motto. Thank you. Thank you very much.
Thank you, sir. The session is open for the discussion.
Dear participant, unmute yourself. May I ask your queries?
Hello.
एवढं टीचर मात्र लिहिलं काही दिसून नाही
Yes, Priyanka
There
ma'am.
is interruption. There is interruption. Okay, sir.
Hello.
There is interruption, sir. Okay, sir. Thank you, sir. So Ritesh Deshmukh delivered, Dr. Ritesh Deshmukh delivered a very good and knowledgeable talk on multi-coated and white light pyrophosphates and phosphorus of eco-friendly lighting application, and he focused on various aspects of these compounds, synthetic technique like that of characterization, and it is very good and useful talk, and it is useful to the researchers also. Thank you, sir, on behalf of the organizers and all the participants. Now, let us move to the last part of the session. I would like to invite Dr. Bageshwar, sir, for the vote of thanks.
Bageshwar, sir, unmute yourself. Hello. Bageshwar, sir. Bageshwar, sir. Hello.
Okay, sir. I will continue.
Bageshwar, sir. Yes, unmute yourself, sir, from your side. Bageshwar, sir.
Okay, sir. Can I continue, sir?
1 minute. Bageshwar, sir, unmute yourself. Thank you, ma'am, for having a great session.
Hello.
Sir, you are audible, sir. Yes.
Am I audible?
Yes,
sir.
right.
Okay, sir.
Okay, sir. Sir, continue, please. Bageshwar, sir. Hello. Sir. Bageshwar, sir. I think there is a connectivity issue. Okay, ma'am.
Achha. Thank you, sir.
Thank you, ma'am.
I would like to
for having a great session.
I would like to thank all the speakers and their interesting and for their interesting and stimulating contribution, and also I would like to thank all the participants for their valuable discussion and patience hearing. Session is not successful without the audience. So I would like to give the special thanks to the audience. Thank you. Thank you.
Thank you, ma'am. Now the technical session 2 will take place in the 2 parallel sessions. Dear participant, please mind the technical session 2 will be takes place in 2 parallel sessions. 52 to 82 will be here in the same link. OP 52 to OP 82 in the same link, and OP 83 to 111 in the Raman room, and link will be already shared in the WhatsApp group. Dear participants, separate link has been sent in your WhatsApp group. Okay, thank you, ma'am. Bansod sir.
Yes, sir.
Now you are the co-host, sir.
Yes, sir. Good afternoon to one and all.
Yeah, good afternoon, sir. I hand over this responsibility
Hello.
of the technical session to Honorable Dr. Amit Bansod, sir, in the same room.
Thank you, sir. So good
Bingley,
afternoon.
sir.
Good afternoon, everyone. Please, the participant who are having oral presentation right from 52 to 81, please rename their identity as OP followed by their number. Please. I welcome Dr. Kaneshwar Nath, sir.
Bageshwar, sir.
I
Bageshwar,
welcome
sir,
Dr.
session is over.
Kaneshwar Nath, sir, the chairperson of this technical session. I welcome you, sir. Ganesh Nath, sir. I welcome you, sir.
Nath, sir. Nath,
Hello.
sir.
Nath, sir, please unmute if you.
Yes, sir. Now, Nath, sir is the co-host now.
Yes, sir. Yes, sir. But he yet to be muted, sir.
सर काय कनेक्शन नाही झालाय का
सर झालं ना सर ड्यू टू टाइम लिमिट.
ओके 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 बरं बरं बरं
आवाजच येत नव्हता.
थँक्यू हो काय माहित काय झालं
Nath, sir.
ओके सर थँक्यू थँक्यू
Am I audible to you, Nath, sir? Meanwhile, the participant please rename their identity as oral presentation followed by their number, please. Ankita, Rajesh Kakru, Rajeshri Gatpaile, Prashant, everyone, respected speakers, please rename. Meanwhile, our chairperson will join. Nath, sir. Good afternoon, everyone. You please rename your identity so that we could identify the participants who are present for this technical session in this room. Nath sir, good morning. Good afternoon, sir.
Hello, sir. Good afternoon, sir. Good afternoon, sir.
Good afternoon, sir.
Thank you. Thank you.
So, the today's chairperson from this technical session 2 is available with us, Dr. Ganeshwar Nath sir, Associate Professor, Department of Physics, Veer Surendra Sai University, Burla, Sambalpur. This is in Odisha. So I welcome you, sir.
Thank you, sir.
Sir, please brief the participant about the sessions that is to be going on.
Okay.
Mansoor sir.
Yes, sir.
Mansoor sir. One welcome of the sir, please.
Yes, sir. Sir, I welcome you, sir. I already welcome, sir. And our beloved convener, Dr. N.R. Pawar, sir, will virtually welcome Dr. Nath, sir. Please, Pawar, sir.
Yes, sir.
Thank you, sir.
Yes,
thank
sir.
You,
This
sir,
is a small
for a nice introduction about me. Thank you, sir. Forward, sir. Thank you.
Okay, sir. We'll post it very soon, sir,
Thank
on
you,
your register address, sir. Okay, sir.
Okay.
Thank you.
Okay. So let me discuss with the presenters. Those are already in the line. So, dear candidates, you have total 8-minute presentation. Out of this 8 minutes, there is 7-minute presentation. 1 minute is your question answer. So all we try to stick the time, and during this, all participants are requested to unmute their microphone so that it can be clearly audible. So, sir, anyone is there, sir? Please, the list is, sir. Hello.
Sir.
Yes, sir. The list is from 52 to
82, sir.
So, shall I invite? Yes, sir.
Yes, sir.
So, Mr. Bhushan Hasmukh Bhati, Assistant Professor, Indira Gandhi Kala Mahavidyalaya. Anyone is there? Hello?
Bhushan.
Mr. Bhushan Hasmukh Bhati, OP 52.
Now, sir, if possible, we will continue with the presenter who are available right now. I have seen that oral presentation 63 is available with us. So
okay, so please, sir, if it oral presentation 63 available, Sandeep Barma is here. Yes, Sandeep Barma.
Sir,
Sir.
Respected sir.
Yes.
May intimate to participant rename their name as OP.
Yes, sir.
That
OP.
will be convenient to all.
Okay, OP 63. I think Sandeep Barma is already. Sandeep Barma, sir, he needs actually to be on mute, sir. OP 63 is to be on mute.
And to be co-hosted also.
So I'm the co-hosted, sir. Okay, let me. OP 63. Okay. It's not.
Good afternoon, everyone. Am I audible?
Yes, you are audible.
Okay, sir. So now I'm going to present my screen. Sir, kindly give me permission.
Yes. Sandeep?
Yes, sir, I'm doing that.
Yes.
Right.
So my screen is visible?
Yes, visible. Yes.
Okay. Yes, sir. Sir, all respected dignitaries present here. I am Sandeep Verma, scholar of PhD in Sarda University, Greater Noida, and I am doing my PhD in the supervision of Dr. Krishna Kumar Pandey. So thank you for Dr. Krishna Kumar Pandey. Sir, contents of my presentation, that is introduction, physico-chemical properties, and application and the future perspectives, and conclusion, then references. So this is my abstract of the, my title of the presentation is ultrasonic characterizations of different polymers and the organic liquids, a review. So this is introduction. So this paper consists the ultrasonic techniques as and the alternate to the characterization of the polymers, polymers and the organic liquid over other understand techniques. The current review presents ultrasonic techniques as more systematic, malleable, and the appropriate for the characterizations and fulfill the requirements of the industries. So sound velocity measurements are always been attracted due to their various applications, particularly for the chemical industries. Understanding of the sound velocity and its variant are exponentially used in characterization the liquid such as the electrolytes and the organic solutions. In modern era, the quantification of ultrasonic velocity has been appropriately worked in the considerations of the nature of molecular intermolecular interactions and the intermolecular force and the intermolecular arrangement. Ultrasonic parameters submit precious information regarding the behavior of the molecules in liquid system because intermolecular and intermolecular association, dipolar interactions, complex formation, and related structure change and affect the compressibility of the system. By finding the ultrasonic velocity, we can find the several parameters like the adiabatic compressibility, like the acoustic impedance, like the relaxation time, which are useful to finding the characterizations of the molecule. In intermolecular force is a function of the concentration of the liquid and the temperature. But variation in the temperature shows more effect than the concentration. At the low concentration, there may be less number of the hydrogen bonds. And at the high concentration, there may be more number of hydrogen bonds. This paper consists the study about the molecular behavior in the single organic liquids, binary and ternary mixture of the some organic liquids, and in the polymers. The investigation regarding the molecular interactions in some organic and ternary liquids mixture as explained. So my next is the second heading, and this is physico-chemical property. Ultrasound develop physical and chemical changes in the liquid. When they propagate, there will be the continuously rarefaction and the compression. So ultrasound develop physical and chemical changing in the liquid medium and produce distractions of the cavernation bubble. So ultrasound is propagated through a series of rarefaction and the compression wave, include the molecular of the medium through which is passed. So first liquid that is I have studied in the several research paper. First one is the polyvinylidene fluoride. So polyvinylidene fluoride (PVDF) has an symmetric line and the simple chemical structure. PVDF has a ferroelectric and the pyro quality. Sir, pyro qualities are two main important qualities. Piezoelectric effect, that is ability of a certain material to generate the electric charge under the effect of the mechanical pressure. And sir, while pyroelectricity is the ability of the material to generate the electric charge when subjected to the heat. So, piezo quality PVDF contain. These quality have the vast use in the device application, like the sonar instruments, solar cell, ultrasound transducers, etc. So, the literature in PVDF help us to relate the effect of the concentration and the nature of solvent of molecular interactions in the polymer. The polyvinylidene acetate is used in the adhesive of materials. Third one I have learned from the several research paper, that is the polyvinyl acetate. And third one is the dimethyl formamide. Second one is the dimethyl formamide. So dimethyl formamide is a polar molecule which has the dipole moment as equal to the nitrobenzene. When DMF relate the nitrobenzene, then dipolar interactions is obtained, and volume of the mixture going to decrease due to the small size of the nitrogen and nitrogen DMF and the linear aliphatic configuration. Nitrobenzene is comparatively complex molecule. It is non-ideal due to its polarity arise out of carbon and the CN bond.
Sandeep, hello. Sandeep.
Yes, sir.
It's already 7 minutes there. So please try to complete in time.
Okay, sir. Okay. So this is the table which represent the details, which I studies details of the properties of the several organic liquids, which I studies in the several research paper. In PVDF, when it mixed with the acetone at the concentration 0.2% at a fixed frequency 1 megahertz, so density will be 784.1 kilogram per meter cube, and viscosity is 0.3672, and ultrasonic velocity I learned from that from the Kulkarni, SS Kulkarni et al. Paper. The adiabatic compressibility, there is no reading of the adiabatic compressibility. And second thing is the aqueous solutions of the aqueous solutions of the double digitaline water, and it is the concentration 0.6 at the fixed frequency 2 megahertz and at the temperature 303 Kelvin, and density will be 1.043. So these are the parameters which I studied from the several papers of the several researchers. So this is the applications and the future perspectives. So we have several applications of the binary and ternary liquids. So therefore, from the above observed result from the different research papers as shown in the table as a whole, it can be studied that these findings of the various research paper as the reviewed will definitely help a lot for the different research. So this is the conclusion, sir, for understanding the nature and the strength of the intermolecular forces in the liquid. Ultrasonic technique is the important tool. Nowadays, ultrasonic is a depending field for the research, which has been used to polymer as well as the organelle liquids. So this is the next, sir. These are the references, and thank you, sir.
Thank you. Now the paper is open for discussion. So if the participants are maybe asked questions.
Yes, sir. I am ready.
Yes.
माझं शेअर करा थांबा त्यांनी अनाउन्स केल्यावर शेअर करा अनाउन्स करून द्या.
Pandey sir, good afternoon.
Hello.
Yes, sir.
Anyone can ask the questions. The questions, the paper is open for the discussion.
त्यांनी शेअर करा सांगितलं शेअर करा.
Yes. So if there is no questions, then let me ask questions. Sandeep. Hello?
Yes, sir.
Yes. So why you just make a thorough study in the for ultrasonic? What is the unique features that associate with the ultrasonic wave that you want to make it a technology for the study of the for different liquid mixtures. What is the technology behind, or what is the uniquity that associate to the ultrasonic?
Sir, actually, ultrasonic waves are for finding the intermolecular structure, molecular arrangements of the liquids. So we should use the ultrasonic techniques, and by using the ultrasonic techniques, we can find the characterization of the material, and we can use in the several applications of the daily life. Just in the medical life, we can in the medical field we can use, in the textile field we can use the characterization of the objects. So sir, that's why I selected this.
हाँ सर. हो सर हो बोला.
Yes.
हे ते सुरू आहे टेक्निकल सेशन अँकरिंग.
Okay. Okay.
पहिला रूम
Bansal sir.
99 sir. हाँ sir.
Okay. So let the Sandeep. Thank you for nice presentation.
Thank you very much, sir.
Okay. Thank you. Thank you. The next, Bansal sir, which is the next actually?
OP59 is available, sir.
OP59 to? Okay. Yes, OP59, Sachin Dattara.
Ralegankar.
Yes.
Yes, sir. I'm.
Okay.
Okay, sir. I will share my PPT.
Okay.
Sir, screen sharing disabled.
Sir, 1 minute, one minute, sir.
Okay, sir. Okay, sir. I will wait.
Okay, Lamrud sir, now you are co-host, sir. Okay, you may share your screen.
Okay, sir.
Okay, sir. Madam, good afternoon, madam. हो आता पाठवतो. ठीक आहे. ते काय झालं?
हॅलो.
बरं. ते काय झालं माहितीये का?
सचिन दातार.
हे करायचं होतं ना, ते सेशन.
सचिन दातार.
बिलकुल पाठवतो. हा.
Yes, Dr. Sachin Dattara.
राईट. ठीक आहे ना मॅडम. हा बिलकुल मॅडम. हा पाठवतो मॅडम. चला हा सर.
हाँ सर, आई एम शेअरिंग सर.
बिंजवे सर आहे तिथे. हो बोला ना. हो 1 मिनिटात पाठवतो. ठीक आहे. Prasad sir, you may share your screen, sir.
Yes, sir.
Prasad sir, start your video.
Dattara sir. Hello.
Hello.
Parar sir, I think.
Is it visible?
No.
Yes sir. Okay sir.
Yes, visible.
Okay, it is now visible.
Visible, okay. First.
Parvar sir, it is OP59.
Yes sir, there is some technical issue, sir. Okay sir. Okay, we'll wait 1 minute, sir. Okay.
Okay, no problem.
Okay, sir. Can you see my screen, sir? There was some technical issues. Slide we cannot see, sir.
You are audible and you are okay. Your screen is also visible, sir. Okay, sir. Proceed, sir. Okay, continue, sir.
Okay, sir. Good afternoon, everybody. Myself is Dr. Sachin Dattara. I am from Ahmednagar College in Maharashtra. So I have done preliminary observation on the dye sensitized solar cell. You know that the dye sensitized solar cells are devices for the conversion of light and electric energy by mimicking photosynthesis of plant. You know that photosynthesis of plant, there are two photosynthesis, photosynthesis 1 and photosynthesis 2, which depends upon the Z and thermoluminescence techniques. I am not going into the much more biochemistry of it. Grezel and O'Regan in 1991 invented prototype dye-sensitized solar cell. In the beginning of development of this cell, the dye were made from ruthenium, but because the availability of the ruthenium is limited and difficult to make, many researchers which are beginning to switch on to the natural dye. Then the leaves of flower, petals, bark, fruits of the plants can be used as a dye for the dye sensitized solar cell. The extract will be taken from these. The main advantage of using natural pigments as a sensitizer in dye sensitized solar cells are low fabrication cost and easy availability and flexibility and the supply of raw materials and non-environmental risks and multicolor options. In our project, we have taken the three plants, Aboli, Krishna Kamal and Axora flowers, and the characterization we have done. Next. The construction of dye sensitized solar cells is like this. The counter electrodes, sealing gasket, electrolyte, organic dye, titanium dioxide nanoparticle, and the transparent conducting materials. In transparent conducting glass, it is transparent conducting oxide glass of fluorine doped tin oxides film, which is used to collect the electrons from the sensitized dye. Then the titanium dioxide nanoparticles are widely used as the photo anode materials. A layer of titanium dioxides nanomaterials is used. The advantage of this is it gives the best photocatalytic activity under the ultraviolet irradiations. The absorption spectra of these pure titanium dioxides does not absorb the solar radiation above 320 nanometers. Hence, the titanium dioxides needs a dye sensitizer to become a good solar cell photoanode materials. So these are the pictures which I have shown. We have collected this in the Pune University, Dr. Habib Pathan's laboratory. There we have carried out our observations. The preparation of this paste will be mentioned in this my slide. Next, the natural dye. The natural dye obtained from Aboli, Krishna Kamal, and Axora flowers, natural pigments like chlorophyll. You know that the chlorophyll is a green pigment which is present in the plant leaves. Then carotenes, anthocyanin are freely available in the plant's flowers. And these are we have collected in our college campus. Our college campus is widely spread over 75 acres. Our college has a huge campus. Then the flowers were brought into the laboratory, washed and in distilled water and cut into small pieces.
Hello, Sachin
Hello.
sir.
Yes, sir.
Yes, sir. So have you shared your screen, sir?
Yes, sir. I have shared.
But sir,
It is
not visible
huh?
actually.
I asked you before beginning.
So your share screen is not visible, sir.
Not visible?
No, sir.
But somebody from your side told me that it is visible.
No, sir.
No, sir. Okay, sir.
I'm not able to
Sorry.
see your.
Okay, sir. I will share again, reshare again.
Please, sir. Please, sir.
Okay, sir. Just a minute.
Yes, sir. It is now visible, sir.
Hi.
Thank you, sir. Thank you.
Okay, sir. Shall I start from begin or shall I continue from
no,
this?
No, sir. Please continue, sir. No problem.
Same slide or shall I start from begin?
No, sir. You can. You can.
Okay, sir. Okay, sir. Then these flowers are brought into the library and washed with the distilled water and cut into a small pieces. Then the chemical used for the extraction pigment was 8.2 ratio, whose ethanol and distilled water, and the flower pieces are kept into the solution for 24 hours, which gives a good amount of pigments. These pigments are then filtered with muslin cloths, and the filtrate was separated by using petroleum ether with the help of separating funnel, and this result in preparation pigment properly. And the pictures are shown here. All this work we have carried out at Savitribai Phule Pune University, Dr. Habib Pathan's laboratory. And so these are the three plants which I have selected for my investigation. The Crossendra infundiformis, this is a Passiflora incarinata, and this Axora coccinea. In Marathi, we call it as Aboli, Krishna Kamal, and Axora. These are the electrolytes and the counter electrodes. And this is the slides coated with the counter electrodes. And this is the structure of the dye-sensitized solar cells, which is shown in this particular slides. And the fabrication of this is a fabrication procedure is mentioned here of dye-sensitized solar cells. Next. So these are the few pictures from the laboratory which I have taken, and the photographs are pasted on this particular slide, which I am sharing with you right now, sir. Next. And this is the mechanism of dye-sensitized solar cell, which is shown here. The main process that occur in the dye-sensitized solar is the incident photon is absorbed by sensitizer, absorbed onto the titanium dioxide surface, and the photosensitizers are excited from ground state to excited states, which is shown with the asterisk signs, and the excited electrons are injected into the conduction band of the titanium dioxide electrodes. And this is the mention with the what I just now shared orally is mentioned in equation S plus this is the H nu plus S star, that is in excited state. Then it gives rise to what S plus electrons, and the injected electrons in the conduction band of titanium dioxide are transported into the nanoparticle, and the diffusion towards, and the electrons finally reach to the counter electrode through the circuits. Next. And the advantage of this particular procedure or the technique is that it is a low cost, simple preparation techniques, and the clean and environmental friendly. This is the most advantageous things for this particular technique, which I have used for our investigation. Next. And the disadvantages are few. The major disadvantage to the dye-sensitized solar cell design is the use of the liquid electrolyte, which has a temperature stability problems. At low temperature, the electrolyte can freeze, and the ending power production and the potentially lead to the physical damage. And the next disadvantage will be higher temperature cause the liquid to expand and making sealing the panel a serious problems. That is the major problem created if you have not taken the utmost care. Next.
Oh, Sandeep sir.
Yes. And the result and the discussion, which are the preliminary result which you obtained from this investigation, I am sharing with you, sir, right now. The natural dye titanium dioxide exhibits.
Yes, Sandeep sir.
Exhibit a good absorption peak between the end of the ultraviolet region and the beginning of visible region. This implies that this type of dye molecules are strongly bound to the oxide surface, and the graph shows these are the few graphs of Aboli dye, Krishna Kamal dye, and the Exora dye. And this is the IV characteristics. The short circuit current is the current across the solar cell when the voltage passing through the solar cell is 0, when the solar cell is short circuited, and the open voltage current is maximum available from solar cell, and this occur at 0 current. Fill factor, which is described as the rate of the maximum power from the actual solar cell per maximum power from the ideal solar cell. The efficiency described as the ratio of the energy output to the solar cell to the input energy from the sun. Next slide. So these are the voltage versus current IV characteristic diagrams. Next. And these are the performance tables from these three particular plants which I have taken for our investigations. And the conclusion of my or inference from my investigation is that the natural pigment from these plants are preferable due to its low cost and environmentally friendly, abundant in nature. Their availability is more and easy to synthesize. Then the dye-sensitized solar cell has been considered to be a new generation solar cell technology for the 21st century and is a fast-growing multidisciplinary subject. In near future, this system will promote the acceptance of clean and renewable energy technology. In this project, the emphasis is given mainly on the natural pigment, the extract, which are taken. I have just mentioned the three plants. They are collected from our college campus, as I told you. And this plant that give the main factor affecting the energy conversion efficiency of dye-sensitized solar cell. A dye of passiflora in Carinata and Krishna Kamal flower gives the maximum absorption wavelength, that is around 580.7 nanometer and 0.4 values of VOC. And the Crossendra in form is, that is aboli, what we call in Marathi flower, gives the 439.7 nanometer wavelength and the 0.04 voltage VOC value, and the Exoras coccinea flower gives the 440, which I have already shown in the figure in my previous slides, and the 0.4
Sachin sir, please.
voltage. This study may encourage the further researchers. Yes, sir.
Sir, please try to complete. Already time is here, sir.
Okay, sir. Just within a few seconds, I will complete, sir. This is my last point. This study may encourage further research on a new natural dye sensitizer to enhance the energy conversion of dye sensitized solar cell in near future. Thank you for your kind attention, sir.
Thank you. Now, this paper is open for discussion. So the participant may ask some questions. Hello.
Yes, sir.
The participant may ask some questions.
I have a question.
So please ask questions,
sir. Petro, sir, please.
Hello.
Yes, sir, Petro, sir, you are audible. Please.
Well, I have a question about the decomposition, time of decomposition of pigments which is produced from natural plants. What do you think about that? Because when we use natural pigments, the time during that pigments can decompose is rather short in comparison with synthetic materials.
Yes.
Yes, sir.
Sachin
What do
sir,
you think
please.
about that?
Sir, if you don't mind, can you repeat what is what you are asking about preparation time of dye, natural dye?
Yes, about the time of decomposition of natural pigments.
Yes.
How long do they sustain?
Yeah.
Sir, actually, the exact time I could not tell you right now, but problem is that we are doing the preliminary study. We are in the first stage. So we are still working on this thing. And then we are going to in future. Our future plan is to extend this study for further, but the time is very less, sir.
Okay.
Okay.
Sir, yes, Sachin sir, hello.
Yes,
I have a question. Sir, what is the chemical composition of this Passiflora incarnata for which you have taken as for your synthesis of these nanomaterials?
Anthocyanin and keratocyanin, sir.
Yes. So what is the unique characteristic that associated with that for which you have taken this into account for preparation?
Sir, actually, just now I shared the few characteristics. So in future we are going to do many more, sir.
Sir, have you measured that for the efficiency of that whatever that you have just now product, what of the solar cell that you are doing or talking?
Yes, sir, we are doing, sir.
So what is the efficiency?
But we are not doing the result
of the
with
previous
our
one?
expectation, sir.
Yes, sir.
Still there is a scope for improvisation for me.
Sir, he might not have done it on potential stats, so the proper parameters would not be available with them.
Okay.
Possibly.
Okay. Okay. Right.
The observation we have taken it, but the observation which I obtained while taking which is not to our expectation. Still we are improvising, and there are some little bit discrepancies are there. And these studies were carried out at Savitribai Phule Pune University, Dr. Habib Patan's lab. I think some people might have known to him.
Okay.
The leading scientist in India as far as
thank you for nice information, sir. Sachin sir, thank you. Thank you.
Okay. Thank you very much.
Thank
sir.
you. Next, Bansal sir.
We have 61, sir. Oral presentation 61. Prasad sir also. I hope he has presented. Then oral presentation 81, sir.
81.
Shrinish.
Yes.
Mohit.
Yes. OP 81. Shrinish Abhaya Mohit.
Yes, sir. Yes, sir. I'm present here. Just give me. I'm sharing my slides, sir.
Yes.
Sir, please give me permission for sharing my slides, sir.
Sir, 1 minute, sir. 1 minute, sir. Okay.
Yes, yes.
Okay, sir. Now you are co-host, sir. Okay, please share your screen.
Yes, sir. Thank you, sir. Yes, yes. Thank you, sir. Is it visible, sir?
Yes, sir. Yes, sir. Please continue, sir.
Uh, so very good afternoon to one and all present here. My name is Srinish Mohiti. I'm a pharmacy student in Department of Pharmaceutical Sciences, RTMNU, Nagpur University. I'm pursuing my M Pharmacy under the guidance of Dr. Jasmine Avari, madam. So today is my presentation topic is a formulation and evaluation of chitosan nanoparticle incorporated in the in situ nasal gel for Parkinson disease. These are my contents of the slide. This is my abstract for the abstract of my study. In this abstract I mentioned the introduction about the Parkinsonism disease, then the need of the nanoparticles in the use of the Parkinsonism disease in the medication, the Parkinsonism, the main then the formulated chitosan nanoparticle by I formulated the chitosan nanoparticle by using ionic gelation technique. Then it is formulated with help of Poloxamer 407 in a thermosensitive gelling mechanism. Then chitosan nanoparticle for evaluated for the particle size, then PDI, zeta potential percentage entrapment of the drug. Then further in situ gelling, prepared in situ gelling was formulated for the viscosity measurement, in vitro diffusion study, ex vivo drug permeation, and stability study. This is my overall research methodology for the preparation of the chitosan nanoparticle. Chitosan nanoparticle is firstly chitosan is mixed 0.5% chitosan is mixed with the 1% acetic acid. It stir vigorously on magnetic stirrer for the 3 hours. Then I am adding the addition of the cross linking agent, which is sodium tripolyphosphate in the in concentration of 0.1% to 0.022% solution. Then that solution is stirred vigorously for the 2 hours. Then the prepared solution is centrifuged for the 15,000 rpm at 4 degrees Celsius for the 15 minutes. This is the formulation of chitosan batch using the 3:2 factorial design, which has used in my study. In this all prepared batches, I use F8 batch as my optimized batches. Here is are the some picture of my formulations where TPP 0.1%, TPP 1%, and TPP 2% are the solution. The reason behind the showing these images is because I'm try to try to explain the effect of the TPP in the present nanoparticles. The TPP 1% solution shows the some precipitation in the formulation. It means it more the precipitation shows the more the particle size. That's why the TPP 1% solution and TPP 2% solution is not useful in this formulation. That's why TPP 1% solution is used for the further solution, which is optimized batch of F8. Then preparation of thermosensitivity gel is used. Formulation of thermosensitivity gel is prepared by cold method, initially in very small quantity of uh, water. Poloxamer dissolved separately in concentration 20% weight by volume at the cold condition. Then HPMC dissolved in the quantity as specified in the composition table. Later APIs and PEG. Here is the API I use is the nanoparticles, chitosan nanoparticle developed with the drug using selegining and levosimendan. Later, PEG 400 methyl parabol incorporated and stirred until the clear solution was obtained. Finally, made the final volume up to 100 ml with distilled water. Keep overnight freezing under the condition 4 to 10 degrees Celsius. Here are the test or the characterization I am performing for the nanoparticles. FTIR studies and FTIR spectra of levodopa, then selegin hydrochloride, and the other then FTIR study of the nanoparticle as is measured. Then DSC study of the drug and and the formulated nanoparticle is measured. Then the average particle size and polydispersivity index, particle size using the Malvern zeta sizer, virgin probe sonicator nano used for the measurement of average particle size, which is the main. Then the zeta potential of the drug, loaded chitosan nanoparticle was measured. Particle is system probe sonicator used. Then drug entrapment efficiency was separated by the using is examined, and this formulation using this formula. Then the evaluation of the in situ nasal gel. In evaluation of in situ nasal gel, I do the test of clarity, then pH of the gel, measurement of gelation temperature, then the drug content estimation, and then gel strength, viscosity, and in vitro diffusion study of the gel. In in vitro diffusion study, I use the France diffusion cell apparatus for the, then it is for the 8 hours using the goat nasal mucosa for the then ex vivo permeation study. Nasal cavity of drug was obtained from the nasal cavity of goat is obtained, and then the further study is performed. These are the results of the FTIR, levodopa, FTIR spectrum of selenium hydrochloride, FTIR spectrum of nanoparticles. Then this is the zeta potentials optimized of batch of F8. Then this is the surface response from the particle size, PDI, zeta potential, personal levodopa, selenium effect of then. And then this is the results of the DSC study. Further, the in situ gel formulation will be then I will be examining the other formulation characteristics for the in situ gel formulation. Thank you.
Thank you. Yes, Srinivas. Hello.
Yes, sir. Yes, sir. Yes.
Yes. Now the question. Now the paper is open for discussion. So the participant required to ask the questions or any queries. Hello. Yes.
Yes, sir. Yes, sir.
Yes, the participants are required to ask of any queries about this.
Dear participant, may unmute yourself and share your queries.
Hello.
Yes, sir. Yes.
Yes. Anyone?
Okay, sir.
Okay.
Okay.
Sir, now, sir, please 1 minute, sir. Okay. It's a great pleasure to have Professor Valmir V. Petro with us, sir.
Yes,
You are
sir.
most welcome, sir. I am extremely pleased to welcome Professor Petro, sir, on this e-platform.
Please, sir.
Thank you,
Please,
sir.
sir. Share your ideas, please, sir. Petrov, sir, please.
Yes, sir. You may share your ideas, sir. Okay, sir.
Sir, please, sir.
Well, what do you think from me to say?
Hello, sir.
Well, I didn't catch. What do you think? You're waiting for a question from me?
Yeah, sir. You
Yes,
may
sir.
ask
Yes.
questions, sir. Okay. To participant
So,
at the
up
end
to
of the
now, I
presentation.
had no question about this report because, just one question probably about possibility to use this material, PPT, for creation of nanocapsules. Nanocapsules for probably it's possible to create the array of nanocapsules from this material. What do you think about that?
Thank you, sir. Thank you. Thank you for sharing, sir, your ideas about this person. Thank you, sir. Okay. Thank you, Srinivas Abhay, for a nice presentation. And this time also, Professor Neptov is here. So, on your nice comments on your paper. Thank you.
Thank you, sir. Thank you, sir.
Thank you.
So the next presenter is OP62 Rajendra Mankar. He is available, sir.
Yes, OP62.
Good afternoon, sir.
Rajendra.
Good afternoon, sir.
Just start now.
Can I share, sir, my slide?
Yes, you can share.
Please allow, sir.
Yes, sir. Yes, sir. OP62. Okay, sir. Now you are co-host, sir.
Okay, sir. Thank you.
Okay.
Rajendra sir, you can share now.
Yes, sir. So slides are visible.
Yes, yes, it is visible now.
And sir, please confine yourself.
Good
within
afternoon,
7 minutes.
everyone. Myself. Okay, sir. Good afternoon, everyone. Myself, Mr. Rajendra Mankar from Anjangaon, Suruchi. And my presentation topic is synthesis and characterization of pure and CE modified SMFU3 thick films. We all know semiconductor metal oxides have created a great opportunity in various applications. This is because of their unique physical and chemical properties. Further, they have a wide range of applications, number of applications like solar cell, gas sensor, catalysis, etc. In this, the application of my interest is particularly gas sensor. So why there is a need of gas sensor? So detection and monitoring of hazardous gases emitting from the auto and industrial exhaust is strongly required all over the world for better quality of air. Number of methods are available for the detection of environmental monitoring. Among these, the gas sensor based on solid state metal oxides have proven to be the most promising devices. When we talk about gas sensor, the three sensing properties comes there, that is sensitivity, selectivity, and stability. Further, the operating temperature. From that time, number of metal oxides were studied for gas sensor, single metal oxide like ZNO, SNO2, IN2, O3, and WO3. But they suffers from many drawbacks like low response, high working temperature, and poor selectivity. So the next option comes, that is use of mixed metal oxides like spinel type, etc. Meanwhile, the perovskite type semiconductor metal oxides were also reported to have a great sensing properties. So we select here a perovskite type material, and the material is SMFU3. So what is SMFU3? It is a perovskite type material having general formula AbO3, where A is rare earth and B is the transition metal oxide. SMFU3 is a p-type semiconducting material. That means its conductivity increases for oxidizing gases and decreases for reducing gases. Initially, as I said that it is a p-type semiconducting material, so it is more suitable for oxidizing gases only. It was the restriction, and initially the research was limited to study only for the oxidizing gases. But why we select this material? The first reason is its perovskite structure, that is AbO3. This perovskite structure permits the partial substitution at A site, B site, or both A and B site, and therefore the doping is possible, which may result in greater properties. Secondly, as I said, its use is limited for oxidizing gases. But when we dope this pure SMFU3 with some dopant, then there is a possibility to use it for reducing gases. For example, the cerium is A side is doped with cerium, and it was reported that it can be used for the reducing gases also, because it produces the high reduction conditions. It remains stable, shows no phase change at high temperature near about 900 degrees Celsius. And the third way why we choose this material, because the easy synthesis method like sol gel method, co-precipitation method, thermal method, with all these method, it is possible to synthesize easily the SMFU3. So therefore, there is a great technological versatility for sensitive material of SMFU3. Now, this is the process I adopted, that is sol gel method for the synthesis of pure SMFU3 method. Initially, the stoichiometric amounts of samarium nitrates, iron nitrates, and citric nitrates were mixed in the ratio 1:1:1, and they are grounded in aged mortar for 30 minutes. Then the ethylene glycol was added to this mixture with the constant stirring at 75 degree for 2 hours to obtain a gel. This gel was dried in oven for at 110 degrees Celsius for 12 hours. Then it was calcinated at 800 degrees Celsius for 4 hours. And finally, we get a pure SMFU3 nanoparticles. Now for the fabrication of SMFUP thin films, first the paste was formulated, three processes are included here, that is paste formulation. The SMFUO3 is thoroughly mixed with solution of ethyl cellulose in a mixture of organic solvent like alpha terpineol. And for screen printing, the paste should be thixostropic, and therefore the ratio of inorganic to organic part was kept at 75 to 25. Then substrate cleaning, I used the glass substrate of size 2.5 into 7.5 centimeter square for this fabrication of thick films. The glass substrates were cleaned several times with distilled water and then with acetone. And the screen printing technique was adopted for preparing the screen printing. The thixostropic paste was then screen printed on glass substrate in desired pattern. For the surface modification actually can be done in two processes, that is by doping and the dipping. In doping process, the impurities are dopants are added at the time of synthesis, but it was reported by so many authors, that is doping process. I here select the dipping process for the surface modification of SMFUO3, and the dopant was cerium chloride. The thick film of pure SMFUO3 was deep into cerium chloride mixture for 1 minute, and the solution
Rajendra,
then yes sir,
just try to complete that
yes
timing.
sir. And then this is the X-ray diffraction analysis from the JCPTS card number. This confirms that there is a pure SMFUO3 slides, and this is the comparative surface morphology. First slides shows the pure SMFUO3 FESM for pure SMFUO3, and second one shows for CE dope SMFUO3. Highly porous slides films are obtained there. Grains are also available. This is elemental composition that confirms that there is a presence of CE dope. And my result is there is a possibility of synthesis of fine powder of SMFU3 peroxide oxide by Sol-Gel method in citrate system. For the first time, I tried the surface modification by dipping technique, which is useful. And the surface modification promotes the increased oxygen absorption. This leads to the high sensitivity in case of gas sensor. So thank you, sir. I open myself. Hello, sir.
Yes.
Yes, sir.
Thank you. Thank
So
you,
now the paper is open for discussion. So I request the participant please ask or interact with the presenter so that it will be good, the good communication to all, so that the good application go to the actually the society. So if not actually interact, then there is only presenter will there and will listen, then it will not actually. So please all, I request to all participants please interact with the presenter so that he will be encouraged and he will be do something. If anything wrong, he may be correct. Okay. So please.
Sir, I do have one question. This is Dr. Ramesh Taikar.
Yeah. Please, sir, please.
Yes, sir.
Sir, tell me how on the last slide you have quoted the last statement, that is oxygen. What you written over there?
Surface modification promotes the increased oxygen absorption.
So will you please elaborate that statement?
Sir, actually, when gas sensing is studied for the role of oxygen deficiencies, what we say, it is more important, and therefore the surface modification just what we said, the increased amount of oxygen absorption, large number of oxygens can be absorbed. Yes, it is a condition for what we said, gas sensing. If more the oxygen, more the oxygen absorption, oxygen vessel, see the sensitivity of that gas sensor increases. But we see
I'm not
sensitivity.
agree with Rajendra sir.
Yes, sir.
What Taikar sir is asking about, how do you claim that oxygen absorption can be increased via
Yes.
surface modification?
Exactly.
See, in the same, if the
Yes.
porosity is less, then also it decreases the absorptivity. Even if it is more than its limit, then also it decreases. So
Yes, Bansu sir,
that,
you are right.
Yes,
that limit,
yes, yes, sir.
how
Yes, sir.
and you have
Within
not
that limit, there should be the dipping.
say, so you have not characterized those things, but it's okay, sir.
Okay.
Okay, sir. Okay, sir. Okay,
Hello.
sir.
Yes,
Thank you, sir.
Rajendra. Hello, Rajendra. Hello. Yeah.
Hi, yes, sir.
So, can you tell me that in the past slide you have written actually that unique physical and chemical property that associate the per semiconductor. So, can you just have a give you what is the physical and chemical, what unique, because all properties are almost all known, but what unique property that you have seen for which you have taken this work into part actually as your research work? Yes, what unique property? What unique physical property you have seen or unique chemical property?
Actually, yes, sir. Okay, sorry, sir.
Okay.
Right now, I
Okay.
can.
Another question is there. So you have taken A site and B site. So can you tell me which site that you should be doped so that it will be more efficient and more active?
Sir, actually, A site, because
site.
A site, if A site is doped, then it offers more stability. At the same time, it offers the improved electrical conductivity. But if B site is doped, then the doping is reported as MgCONI. These are weaker bonds. This reduces actually stability, sir. No doubt they increases electrical conductivity, but doping at Fe site by weaker bond like Mg or ANI, this may reduce the stability, sir.
Okay.
So I prefer for doping at A
Okay.
sites.
Okay, thank you. Then another is there. What is the importance of the profile structure that you have taken actually? What is the importance? Why? Because
Which
have you seen any? Because you see the many researchers also what work in that structure. But what the unique structure? What the unique characteristic that you mark for which you can take this structure as your part work?
unique structure, sir. Yes, there is a. It allows the doping at both AB sites, A and B sites.
This is the only the part unique. Yes.
Quite be one more things, sir.
Okay.
Okay.
Yes, I'm
Okay.
not sure about, sir.
Thank you for your nice answer to queries and also that nice presentation. Thank you. Thank you.
Thank you, sir. Thank you, sir.
Sir,
Next, sir.
next one is oral presentation 75 Vikas. Vikas sir is available.
Yes, sir, I'm available.
Yes. Yes, you
I'm
start.
sharing my screen.
Okay.
Yes, it's
Sir, it's showing host disabled participant screen sharing. So please allow me.
Sir, please wait, sir. Please wait.
synthesis characterization of bifiber material for shielding.
Vikas sir, now you are co-host.
Okay, sir.
Please
Thank
share
you.
your screen.
Is my screen visible to all?
Yes, sir. Yes.
Hello. Good afternoon, one and all. I'm Vikas, working under the guidance of Dr. Vikas Leharia, MIT University, Gurugram. I'm glad to be a part of this international conference on recent advances in material science and nanotechnology. I'm presenting a review on europium doped zinc aluminate phosphor. So here is the abstract of my paper. Zinc-based aluminate material belongs to material spinel oxide, and it's a wide band gap semiconductor having a band gap 3.8 electron volts. And europium doping in zinc aluminate phosphor has a very good application, and it emits an orange red part of electromagnetic spectrum, and hence useful for solid state lighting and optoelectronic devices. So we are discussing properties and utility of material for the phosphor application. There exist various synthesis routes for the preparation of zinc aluminate. In this study, I have mentioned the effect of doping concentration and calcination time, its duration, and various other parameters on the crystal structure and luminescence properties of U-doped zinc aluminate spinels. So this is the outline of introduction to phosphor materials, luminescence, then zinc aluminate, its property and structure, well synthesis routes, and study of rare earth elements, doping, calcination temperature on the properties of zinc aluminate, and then application of phosphor materials, conclusion, and references. So, phosphor which are when they return to ground state after being excited. Transition to low state may apply two processes by radiative or non-radiative processes. In the non-radiative process, energy of emitted photon appears as vibration of Gauss lattice or the heat. Radiative transition is called luminescence. Then aluminates are the compounds which consist an oxygen ion of aluminum, for example, zinc aluminate, magnesium, and oxygen having general formula AXOIZ negative, and it's being found in various chemical elements. Zinc aluminum materials are monoclinical oxide which have the general formula Ap2O4, where A and B represent divalent and trivalent metal ions respectively. Zinc aluminate was first introduced by Swedish mineralogist and chemist John Gottlieb, and a manner of zinc aluminate is commonly known as granite. It's a wide band gap semiconductor with a band gap of 3.8 electron volt and appears to be promising host material with high luminescence efficiency and high thermal and chemical stability. And since the band gap is 3.8 electron volt, it's transparent for the wavelength greater than 320 nanometer. And the structure of aluminate. Zinc aluminate unit cell consists of 8 FCC unit cells, where divalent zinc ions occupy tetrahedral sites and trivalent aluminum ions occupy octahedral sites. It can be represented as Ab2O4 because divalent cations on tetrahedral sites and trivalent cations on octahedral voids and oxide ions make the ratio of 1:2:4. That's why we can represent it by Ab2O4. There exist various synthesis routes by which we can synthesize phosphor materials. Among them, widely used synthesis techniques are solid state reaction method, combustion method, sol gel method, and co-precipitation technique. However, combustion technique is most reliable because it produces very small grain size phosphor at high speed with less energy consumption. It's also known as SHS technique, that is self-propagating high temperature synthesis and doesn't require repeated heating. We use starting materials in this are in the form of nitrate, and urea or citric acid are used as organic fuels. Here is the basic block diagram of combustion method. We take the metal precursors, fuel, and then add these to deionized water. Stir it at a temperature around 80 degrees Celsius. Then we get a gel. Then we transfer this gel to Mughal furnace preheated to temperature greater than or equal to 200 degrees Celsius. Then combustion happens and we get a burnt powder, which can be grounded using mortar and pestle, and we get another wet chemical technique, which is popularly used, is sol gel technique. It involves series of chemical processes like hydrolysis, gelation, drying, and thermal treatment. It's an old technique which was developed by Ram in 1864. We characterize a sol as a colloid of solid particles which are suspended in fluid, and a gel can be characterized as which have a solid scattering structure which encloses colloidal fluid. To get the powder gel can be sintered or baked. This process produces advantage like materials which are produced by this method are homogeneous and porosity and size of pores can be controlled. This disadvantage of this process is this: if the process of drying or annealing must be slow, otherwise there are striation or cracks. And to dispose of the organic growth, samples must be annealed at a temperature above 1000 degrees Celsius. This is the diagram. Then rare earth elements and their optical properties. Rare earth elements are widely known as or popularly known as lanthanoids and are very significant in regard of phosphor and solid state lighting. The lanthanoid family elements have identical electronic configuration like this xenon 4f and minus 1 to 5g0 6s2. For rare earth ions, 4f intra-configurational transition is parity forbidden according to Lefort selection rule and appears to be weak. And since 4f energy level of rare earth ions is shielded by 5s and 5p cells, their optical properties are not affected by their emissions. I'm reporting here the EU rare earth ions because they are capable of red emissions. And line-like emission occur from higher 5D0 excited state to low energy ground state of 7FG. Energies can be very 0 to 6. And these are significant because of its 5D0 to 7F1 and 7F2 transitions, which emit in orange and red spectral regions respectively. Here is the comparative study. I have grouped various studies done by the groups. We at all group have doped the sample with less than 7% European concentration using sol gel technique. The calcination temperature range was 600 to 900 and they obtained crystal size of 19 to 34 nanometer. Then Viglush et al. They kept the concentration 0.05 to 5%. Calcination temperature range was 700 to 1400 degrees Celsius and up to 10 to 30 nanometer crystal size was obtained. Then Osorio et al. He kept the concentration 133 and 12%. Used the co-precipitation method. Calcination temperature was 900 degrees Celsius and 6 to 8 nanometer crystal size was obtained. Then Pathak et al. European concentration was 1%. We used combustion. Yes, sir.
Yes, your time is already finished, so please try to complete.
Okay. Then this is luminescence study. Lieto observed that in the 1 to 9% concentration, observed peak were these, and maximum intensity was observed at 618 nanometer.
Yes, please wind off.
Okay. So conclusion is that European top zinc aluminate has potential applications red emitting phosphor, and since white light emission requires 3 phosphors, red, blue, and green. So this is the red emitting phosphor and can be used in solid state lighting. These are the references, and thank you so much.
Okay. So now this paper is open for discussion. So please, participants are requested to ask the questions. Yes. Any questions here? Yes. Benson sir, hello. Hello, Benson sir.
Sir.
Yes. Anyone want to ask questions, sir?
Sir, you have tried only one rare earth for getting this spectrum.
Because hello, Vikas. Hello.
Co-doping is also yes, sir.
Co-doping also you have done, but you have not shown
yes,
it.
Sir. I grouped that in the table, so as the time was running out, so
TB.
I just didn't mention.
And both the peaks are at red side, sir. I hope some of the peaks are on green side, should be there.
Green was for the U2 positive state and red for the U3 positive state.
Okay. Fine. So if the proper synthesis process would have been done, sir, you might have obtained those peaks also.
Because hello,
Okay.
on
Yes,
just
sir.
go to your EV slide.
Which slide, sir? Please.
EV.
This one, sir.
No, EV side. EV spectrum.
Next.
Yeah. No. EV spectrum. 15. Slide number 15. 15. Okay.
Yes.
Okay. Yes. So. Okay. This is your party review, Atna.
Yes, sir.
Okay.
See, sir, you have mentioned there is a red emission. See, the intensity of the red emission is quite less.
Yes. That's what I'm telling. So, what are the P corresponds to? Can you see? Just simple question, fundamental question. What are the P corresponds to?
P corresponds for the maximum intensity.
Maximum
intensity, luminescence intensity.
Maximum intensity. But what it corresponds to? Why till the maximum intensity there? Actually, what is the basic phenomena is there? What is the basic physics behind it? That one.
Electronic transition from
electronic transition
from excited state to intra-configurational transitions.
So, is the electron transition correspond to absorption?
Sorry, sir.
Is the electronic transition from one state to other state is correspond to transition as absorption of energy?
Yes, sir.
Or anything or any other phenomena is there?
Right now, I think it's that phenomenon.
There are several such spectra, no? Vibrational spectra.
Okay.
Okay.
Amin sir. Okay.
Yes, sir. Yes, sir.
Let it be. Okay. Thank you, Vikas, for a nice presentation.
Okay. I will be glad if you give me some suggestions.
Okay.
So thank you, Vikas.
Okay.
Okay, Vikas. Thank you.
Any suggestions from your side, sir?
We will share it.
Okay.
Then because there is a time limit, sir. Vikas.
Okay.
But you
Thank
can.
you.
We can discuss afterwards.
Okay, sir. Thank you.
The next presentation is of Ms. Sunita Jadhav, ma'am. Oral presentation 60.
Okay, thank you, sir. Good afternoon to all.
Good afternoon.
Yeah.
Can I share my side?
Yes.
Ma'am, please wait.
Okay.
OP, sir, what?
60, Sunita Jadhav.
Okay, sir.
OP 60.
Yes, right. Now, ma'am, you are co-host.
Okay, thank you, sir. Okay, good afternoon to all. Myself, Dr. Sunita Jadhav. Here I present my research paper entitled Copper-Silver Bimetallic Nanoparticles Synthesized by the Electrochemical Reduction Method. This is the content of my presentations: introduction, experimental method, results and discussion, conclusion, and references. Nowadays, nanotechnology is very popular due to its wide applications, and that's why this nanotechnology or nanoscience is called as a future of science. And nanotechnology is based on the field of applied science, whose theme is the control of matter on atomic and molecular scale. At this level, the properties of matter are totally different from that of the bulk materials. Now, the nanometer is the 1 billionth of meter, that is 10 raised to minus 9 meters. And this is the chart which shows the relative sizes of cells and their component. The diameter of human hair is about 100,000 nanometer wide, which gives an idea about how small is the nanometer. These are the different types of nanomaterials. Among all these nanometals, we are chosen the nanoparticles because they have high surface area, they show the significant reduction in material usage, and they possesses unique properties, that is, they're totally different from their bulk as well as their molecules. They also leads mechanical, chemical, electrical, optical, magnetic and magneto-optical properties, and they are highly reactive. Now, after the monometallic, we are choosing the bimetallic nanoparticles because bimetallic nanoparticles of noble metals are of high interest in the imaging biomedical devices, including the nanomedicine and heterogeneous catalysis. A bimetallic nanoparticle is a combination of two different metals, that is the mixture of two metals, which exhibit several new and improved properties. Bimetallic nanoparticles can be in the form of alloys, core shell, or contact aggregates. They show the improved activities as compared to the monometallic counterparts. They are cost-effective, stable alternatives which exhibit high activity and selectivity. There are different methods which are used for the synthesis of monometals and bimetals, but among all these, we are chosen the electrochemical reduction methods because this method is very easy and have many advantages over the amounts. Now, this is the typical experimental setup which is used for the electrochemical reduction method, and this setup is connected to the potentiostat which supply the constant current to the systems. This is the schematic diagram for the preparation of copper silver bimetallic nanoparticles by this electrochemical reduction method. Here we use the copper and silver bulk metal sheet as a sacrificial anodes and inert platinum metal as a cathode. The electrodes are placed 1 centimeter by 1 centimeter apart from each other. Acetonitrile and tetrahydrofuran in 4:1 ratio is used as the electrolyte. 0.01 molar tetrabutyl ammonium bromide is used as a stabilizer. The reaction is carried out for 2 hours at 10 milliampere current density. After the 2 hours, we get wine red colored copper silver bimetallic colloidal particles, and these colloidal particles are settled for 1 day. After the settling, these particles are washed with the tetrahydrofuran 2 to 3 times, and then the particles are dried in a vacuum desiccators. And after that, these particles are used for the different characterizations. Now, this is the advantages of electrochemical reduction methods. In the result and discussion, this characterization of nanoparticles, this is the UV visible spectra of copper silver bimetallic nanoparticles capped with the tetrabutyl ammonium bromides. Here, the sharp peaks at 266 nanometer and 354 nanometers confirms the formation of copper and silver nanoparticles. The data is compared with the literatures. Then FTIR spectroscopy. These peaks, this is the 833 and 453, these small peaks are confirmed the formation of copper and silver metal nanoparticles. To study, in the XRD, the intense peaks and lattice parameters shows the monoclinic structures for the copper and cubic structure of silver nanoparticles with the size 8.56 nanometer, which is calculated by the Debye-Scherrer formula. To study the morphology of synthesized copper silver bimetallic nanoparticles, we characterize it by the scanning electron microscope, which shows the homogeneous agglomeration of particles, and they are irregular in the shape. The elemental compositions of EDS clearly shows the formation of copper silver bimetal nanoparticles are formed. Here, the bromine is present in trace amount due to the addition of tetrabutyl ammonium bromide. These are the TAME images of copper-silver bimetallic nanoparticles. These images shows monodisperse copper-silver bimetallic nanoparticles. They are clearly visible in the copper silver bimetallic nanoparticles having spherical shape with 5 to 10 nanometer average particle size. Lastly, we conclude that we have successfully prepared copper silver bimetallic nanoparticles by the electrochemical reductions method. The quaternary ammonium salts, that is tetrabutyl ammonium bromide, used as a capping agent, have played a significant role in controlling the particle size. The powder XRD and HRTM result shows the synthesized copper silver bimetallic nanoparticles are 1 to 10 nanometer in range and spherical in shape. These are some references which are used for this paper. Thank you, Noel.
Okay, thank you, ma'am. Now the paper is open for discussion. So participants are required to ask the questions or the queries. Yes. Hello. Yes, anyone? So, or let me ask questions. Sunita, ma'am.
Yes, sir.
Okay. Okay. How you can say that your copper and the silver are compatibility? That you have seen shown the part EV card, there are part two peaks are there, 266 and the other is there. Okay.
Yes.
So, but how can say they are compatible? How you can test their compatibility?
We are studying so many references regarding this bimetallic nanoparticle, that is copper and silver. And according to this literature survey and the references, we can confirm. We are comparing this data to other.
No, ma'am. Actually, is these two matter are compatible to each other?
Yes, sir.
Have you seen their part electronic configurations?
Sir, can you repeat again?
I'm asking actually, have you seen their part electronic configuration? Is they compatible to each other? Is they accommodate to each other?
Yes, sir. Yes, sir.
Sure. Have you got in the reference or that?
Hello. Yes, sir. I got so many references are there.
Question which are
okay.
Hello.
Another thing is here. Have you think it for the stability of this nanoparticle up to the what is the time period for the stability? Have you checked the stability of these nanoparticles?
Not it, sir.
Hello.
But according to the literature survey, they are stable.
Yes, it was.
They are stable.
Not stable, no? What do you
stable.
know?
They are stable, sir.
Ma'am, not clear. Tell me. What is the stability, ma'am? Tell please.
We are not checking it, sir. Stability we are not checking.
Okay. You know,
according to the literature survey, they are stable. We have to check the applications. The further study is remaining of these particles. We have to only synthesize these bimetallic nanoparticles.
Okay.
Hello.
Yes. Yes.
Hello.
Yes.
Hello.
Yes,
sir.
Sir,
Can I ask one question to ma'am?
Please, sir. Please.
Ma'am.
Yes, sir.
You have shown the FTR. FTR spectra.
Yes, sir.
Yes, sir. Ma'am, can you try it for Raman for the same material?
We are not trying, sir. But if you want to do, you can try the Raman. Actually, if you we have, it is better to take the characterize this sample as much as.
Okay. But for FTR, the for identification purpose, you use any online database or you had some database with you right now?
The online database.
Online database. Can you give me the name?
Online database and the research papers.
Research paper.
Research survey. Yes, sir.
Okay, ma'am. Online which database?
Hello, sir.
Which database? Name of the database which you are used for identification online.
There are softwares, sir, FTIRs and Origin.
No. For identification purpose, ma'am, you have mentioned here for 2873 CS stretching, then CN stretching. For this identification, which database you have used? I just want. I'm interested in the name of that database.
I think sir is asking about the reference. What reference?
References, sir.
Okay, research paper, ma'am, you have used.
Yes, sir. Yes, sir. Research papers.
Okay, ma'am. Okay, ma'am.
Sir,
Thank you.
for more details, you may refer the Perkin-Elmer FTIR spectra. analysis.
Yes, sir. Yes,
they
sir.
have given all the kind of stretching. bending.
Spectroscopy book. There is
Perkin
so many books are available on this spectroscopy.
Books are available now.
There are everything is there in stitchings.
Okay, ma'am. Let me talk to the sir. I think sir has mentioned some name.
Yes, yes.
Yes,
Sir,
sir.
please can you repeat that?
There is a Perkin Elmer.
Perkin Elmer.
Yes, yes.
Okay, sir.
He has given all the spectral band for stitching, bending, and everything.
Yes.
Okay.
Inbuilt database is also
Amit,
available
sir?
over here.
Yes, sir. Yes, sir.
Yes,
Database is also
will be
there.
stop. Okay, thank you, ma'am, for a nice.
Okay. Thank you, ma'am.
Nice
Thank you, sir.
answering
Thank you,
all
sir.
queries.
Thank you.
Thank you.
Amit, Bansod sir.
Yes, sir.
I do
Yes,
have a single question. I will not take much time.
Please, sir. Please.
Madam, you have done wonderful work. What you need to do is, I think you should proceed for transmission electron microscopy of this sample.
Yeah.
You're getting good result, and you should follow the further result also.
Okay, thank you, sir.
Kindly go for it.
Thank you, sir.
Fine.
So, thank you, madam. Sunita, madam.
Thank you, sir.
The next presenter is Mr. Prasad, sir. Oral presentation 61.
Yeah. Am I audible?
Yes, sir. Yes, sir.
Share my screen. Just a minute. Okay. Host disabled. Sir, sharing.
Power, sir, please make him co-host. Power, sir.
Bansod sir, OP 61?
61, sir. Prasad Lamrur.
एक मिनट सर.
The OP 61.
Yes, sir.
Okay, sir.
Yes.
Prasad, sir, now you can share your screen.
Yeah. Are you able to see the screen?
Yes, sir. Yes, sir.
This is OP61. The topic is Raman spectroscopic technique as an effective method for detecting adulteration in an Ayurvedic fungal medicine, Fansomba, that is Felinus. So basically, as we all know that recently Ayurveda has gained much attention due to the problem that are encountered with the other medicine. Another problem is that the Ayurvedic medicines are adulterated, and it is a big challenge to detect the adulteration. And literature mentions so many techniques for the detection of adulteration, like preliminary, the morphological techniques are there, spectroscopic techniques are there by FTIR, or other molecular techniques are there. So we thought of using Raman spectroscopy to determine the adulteration. Now, as far as this fungus goes, the discovery of this medicine goes way back in 1982. In 1982, the medicine was kept for drying in front of one of the Ayurvedic shop. So it was collected, it was identified, and later on, its medicinal uses were revealed through the experiments also and through the literature. And this fungus was used in western Ghats of Maharashtra, though not in the eastern parts of Maharashtra, Karnataka and Gujarat. And this is the survey. So it is revealed that more than 12, 13 species are used by the name Fansomba. And similarly, it is adulterated with also the wood of jackfruit tree. So this we have identified by morphological way. So material methods, the samples were collected from the different localities of Pune, Ahmednagar, Kolhapur and Konkan area. The identification was done by using conventional identification literature, that is Larson and Cope, Paule, Bhosle. And as far as Raman spectra is concerned, we took Raman spectra on I Raman. This is the model number BWS 415785H. And we took the spectral range from 175 to 2700 centimeters per centimeter. Laser power was 30 milliwatt, and the microseconds were 60,000. So this we standardize after using permutations and combination. And the chemical species for each peak were identified using again standard references. And the data analysis, we collected the spectra. It was plotted on the origin. Then some numerical analysis were done after converting the spectra into binary matrix. The neighbor joining tree and the maximum likelihood tree was constructed. And similarly, principal component analysis and multi-dimensional scaling was done using Excel stat. These are the samples which were collected. The samples were named for the convenience. Right. These are the Raman spectra of the samples. Was given. Of course, I am showing only a part. There were about 159 peaks were observed in all the samples. And then the peaks were converted into binary matrix as 0, 1. And then it was revealed that, of course, each sample has its own characteristic chemical species. But with respect to these many the bands, there were problems because all the samples were sharing these many bands commonly. Therefore, initially the principal component, as you can see on your left hand side, and the multidimensional scaling. And this was the plot that was used using PCA1, that is principal component 1. So this did not give a clear picture. Therefore, we narrowed it down to the range 487 to 1686 centimeters per square. And therefore, we observed that there are specific peaks were observed at these wavelengths, that is 487, 582 up to 4136. And PCA1 and PCA2 value explained about 93.796% of the total variance. And this was the MDS and the PCA analysis, which gave a very clear picture. Similarly, the neighbor joining trees, in which all the authentic or genuine samples were clubbed together, whereas the adulterated samples got separated. Similarly, in neighbor joining tree also, the branch length for the adulterated sample was more, and the genuine sample, the S1, S2 were clubbed together. So these are the actual samples. The uppermost was the authentic sample, then adulteration. Coupled with PCA, MDS, NJ, and ML analysis provide an alternative method, and it is quick, rapid. As PCA and MD, clear-cut results, and they gave about 94% accuracy.
Okay, thank you, sir. So now the paper is open for discussion. We should expect the participants should ask the questions. Yes. You good work, sir. Anyone ask the questions? Sir, please go to the first slide, sir. Hello.
Hi, sir.
Okay. Sir, particularly this is a fungal Ayurvedic fungal medicine.
Yes.
Okay. Sir, have you, sir, is it tested or only, sir, only that for research work only that you have done, sir?
No. We are working on its medicinal aspects.
No, sir. Okay, medical aspects, sir. But have you, sir, seen that is? Are you applied it?
Yes. We have used it for the anti-cancer treatment. Similarly, I have prepared a
Sir, have that medicine with you, sir, now?
Yeah, I do have.
So can you show this? Actually, it's a good work. So that's why I'm asking actually. So have the video, sir, please. Can you?
Actually, it is in my lab, and I am presenting from another's lab.
Okay, okay. Because that's a good work. As fungal medicine, Ayurvedic, so naturally it will be a good work, sir. So that we want to see actually what is the. Okay, sir. Amit, sir.
Yes, sir. Yes, sir.
You just want to ask any questions, or otherwise?
No, no, sir.
Okay.
That's it, sir. Thank you.
Thank you
very much, sir.
Thank you.
Okay, sir.
With the chairperson's permission, is there anyone whose presentation is yet to be delivered?
Amit, sir. Hello.
Yes, sir. Yes, sir.
Just can I take with your permission? Can I go for my launch?
Sir, what I am intended to say that there is no one left for the presentation from the list, sir. From the
So
list.
anyone left, sir, please? Anyone is there, sir? Out of this list, anyone is here, sir?
There is no one, sir.
Then, sir, will talk to Parvar, sir, for.
Sir, we could conclude it.
Okay, sir. Okay. So 1, 2, 3, 4, 5, 6. So only 7 papers are there today?
Yes, yes, yes.
Okay. Okay, sir. Then no problem, sir. Parvar, sir. Hello. Parvar, sir.
Parvar, sir.
Hello, sir.
Yes, sir. There is no one is there for presentation more now.
Okay, sir. Okay, sir. You may conclude, sir. Okay.
Okay.
Thank you, sir, for having a great session.
Nice, sir.
Thank you, sir. Having a great session. Okay, you are most welcome, sir. Thank you.
Parvar, sir, please. I'm just looking. We are looking very smart and actually this.
Thank you, sir. Thank you,
And
sir.
YK already have given a nice comment on WhatsApp to you. We are very.
You are also looking a very nice, sir. Okay, sir.
Okay, yeah. So same also is sir.
Bansod, sir.
Okay.
Yes, sir. Yes, sir.
Amit, sir.
Yes, sir.
Okay. Amit, sir. So can I know actually your institute, sir?
Ambedkar College, Diksha Bhumi, sir.
Oh, very good. Fine. Thank you. Thank you, sir. Thank you. Okay. So nicely actually for a very good interaction with me this conference. Actually, all the credits goes to Parvar, sir, actually, because he's allowed us to interact.
Yes, sir. It's proud moment for us, sir.
Conference is for this purpose only, sir.
Yes, exactly,
Yes, sir.
exactly.
Interaction is important. Yes.
Ramesh, sir, how are you, sir? Ramesh, sir?
Yeah, right. Fine, sir.
Fine.
Fine, sir. Okay, sir.
Good.
Okay, sir. Okay.
Okay, sir. Okay, sir. Okay. Thank you, sir. Thank you.
Thank you, sir. Thank you, sir.
Okay.
Bansod, sir.
With the permission of the chairperson and the convener.
Bansod, sir.
Yes, sir. Yes, sir.
Please make one announcement.
Yes, sir.
If anyone remains for delivering oral presentation, okay? Yes.
Not, sir.
Yes, sir.
Sir.
Sir, you have asked for the samples, now, so I have brought the samples. If you want to see,
Yes, sir. Please, sir. Please.
Yeah.
Okay, sir. Okay, sir.
Are you able to see? So this is the authentic sample.
Okay. Yes, sir. It's good.
This is authentic sample.
Yeah.
This is adulterated sample.
Okay.
So adulterated sample.
Okay. Thank you, sir. You are good, sir. Congrats, sir. Actually, nicely, sir. Fine. Thank you, sir. Thank you, sir.
Sir, in situ visualization is there.
Really. They have done the work. Very good work, sir. Fine, sir. Fine. Okay, sir.
So
Amit, sir, thank you for giving me very good cooperation and also good interaction with this session. So thanks to all presenters, those are presenting the papers, have the good work. And I think actually the this session actually giving a good information about many ideas like starting from the part nano till the part actually ultrasonic, and also that's a part good application actually in part medicine. So I think the part Parvar sir actually whatever the thought he was started actually this conference, it was very fruitful for this all this audience and also the presenters. those who are presenting the work. It's a very fruitful conference, sir. Thank you, sir. Forward, sir.
Okay, thank you, sir. Thank you, sir.
Actually, this conference is actually nicely successful because all aspects of the research field actually covered here.
Yes.
Okay.
Thank you, sir.
Thank you, sir.
Okay, thank you, sir. Bansur, sir.
Thank you, sir.
We'll
Sir.
wait for 5 minutes.
Yes, sir.
Okay.
If somebody there, okay?
Yes, sir. Yes, sir. No issue. I'm here, sir.
Yes. Anyone from the participants? Anyone from participants? Okay, no one?
Yes.
1 minute, sir. 1 minute, sir. Sir, 1 minute.
Yes, sir.
Yes, sir. Yes, sir. Sachin, sir.
Yes, sir.
Yes, sir.
So,
Sir, what is your OP number?
Sachin, sir, presentation
59.
is done, sir.
Okay, right, sir. Okay, sir.
59. Sir, I already presented.
Yes, sir. Yes. Sachin,
Okay,
sir,
okay, sir.
presentation is
Okay,
done,
sir.
sir.
No problem.
Okay. Okay, sir.
15 is already presented, sir.
Yes, sir. Yes.
Okay, sir. Sir, it was a nice experience, sir.
Okay, thank you, sir.
Thank you. Thank you, sir.
Thank you.
It's the same, sir. We
Okay,
really
sir.
enjoy with.
Okay, sir.
We really enjoy with. Yes, sir.
Okay, sir.
Okay.
Yes. Any participant who is interested for oral presentation? Yes, no one? Okay. If there is no any participant, you may conclude this technical session.
Thank you all the participants who have joined this technical session. As a participant, I am also enlightened to have the vast information regarding various fields. Those have been shared by the various people actually working in their labs and outside also. My worthy friend Ramesh is also here. Nanda Kishore is also here. They are very true researcher in their own aspects. So thank you one and all. Your ideas and comments will be always welcome so that we will grow up and try to deliver more and more in the next coming conferences. If you have any suggestions, please mail or comment to the conference mail ID, official mail ID. Thank you. Thank you very much.
Thank you, sir. Thank you, Dr. Amit Bansod, sir. Hello, sir.
Sir.
Thank you for having a great session under your guidance.
Sir.
Okay, sir. Thank you, sir.
Thank you for giving me this opportunity, sir. Thank you. So may we leave?
Dear participant.
Sir, session संपला ना आता?
Yes, right,
Yes, sir.
sir.
Okay.
There is no more participants.
Okay.
Okay,
sir,
who is
welcome.
this? Yes. Arfa. Okay. 1 minute, sir. Yes. Anyone from the participant? Okay, no more. Okay, sir. Bansod, sir,
Yes,
you
sir.
may conclude now, okay?
Yes, sir. Yes, sir. Yes, sir.
Right.
So
Okay,
you all.
thank you.
Thank you.
And wish you all a very nice time. Okay. Thank you, sir.
Thank you. Sir.
Okay, thank you.